So good morning, sir.
It's a great pleasure to be amongst you. Most of you from Karnataka only. Karnataka. Some people are from outside?
Yes, sir.
May I know? So 1, 2, then 3. So I think you don't know Kannada. Huh? But rest except 3, everybody is good with the Kannada. Okay, not a problem. So, so first of all, I am very much thankful to Sidhu and Goliman for having invited me to give a special talk, or let's not take it as a special talk, it's a discussion with you all people coming from all the different parts of India. So these 3 people are from which state? From Kerala. Andhra Pradesh. Andhra. 2 are from Andhra, 1 is from Kerala. Okay. Good. So we had your photo? Okay. Thank you. Now we'll have a discussion. So as sir said, probably we have 2 sessions for me to be discussed with you. And here trying to discuss on the panel data by using Gretel. Okay. And so the whole the 2 sessions will be, I'll be discussing with you people in the way. The first will have everybody's, I think, anybody is a faculty here? Anybody is faculty? The one is a faculty. Okay. So where you are working?
Sir, Haveri.
Haveri, Government College. Sir?
Sir, Government First College,
Yarragatis. Madam? Okay. So there are 3 faculties are there. Yes, sir.
Yes, sir, from Tumkur.
Tumkur, Government Degree College? Okay. Navalgone. Okay. So I think there's good combinations of outside state, India, other within state faculties, teaching out. So and most of you are from the scholarship, I'm right? So everybody is scholars other than these people are scholars. No problem. Here, so we will divide the discussion into this way. The one thing what I'm thinking, we will discuss on the regression first, which you already studied in your maybe in your coursework also you have discussed, or maybe in your PC also you could have discussed about the regression analysis. The reason why the regression is to be discussed again and again and again, that in econometrics, any tools you use, any data you make analysis, unless until we have a discussion or the look on the regression analysis, so everything is incomplete. So for that reason, we'll try to have a look into the regression first, and how the regression can be run, especially the OLS model in the Gretel, we'll try to discuss. And some few important readings, what are the things we need to take care there, that we'll discuss. So that's maybe the first session we'll go. And second session we'll try to discuss on the panel data. So that we'll discuss with that. Okay, I hope all of you are installed about your Gretel. I think it's an open software and it's a very simple one also. I hope you could have been downloaded the data with this one, data file also. Okay, so we'll see how it will be used in hours to come now. Okay, fine, without making any delay, we'll start with the regression analysis. So this is very simple, as you all know, the regression analysis means what? Okay, so can anyone tell me what is regression analysis quickly? Regress. What is regression? Can anyone tell me?
The relationship between the 2 variables.
2 variables. Okay. Relation between the 2 variables. What are those variables? Independent and dependent variables. Okay. So it's good. So regression analysis, as you all said, so this is a regression analysis method used for the estimation of the relation between the dependent and independent variables. The main is that there are 2 types of variables will be there in the equation, that is called as that is y equals to. So every time we have to use this is a problem here. Okay, so whenever you are using, that is what is called as, for example, y equals to maybe beta naught plus beta 1 x1, okay, plus en. So this will be the regression, it is all called as. So here this part of the regression is called as a dependent variable, and this is the x is called as the independent, which is called as also called as explanatory variable. Okay, so what is nothing but is that, so here in the regression, so we are always trying to find out the causality between the two variables. It's called as x and y. X and y are the two variables. What is the cause and effect? We'll try to find out the cause and effect between the two variables, or more than that also. If it is independent variables, maybe more also. If this is x1, maybe you will be having beta 2 x2 also, beta 2 x3, so it may continue. So in the regression, so minimum there are two variables will be there. One is a dependent, another one is independent variables. Independent variables can be more than that also. If it is more than that one, that is called as a multiple regression. If it is the only two variables, it is called as a simple regression, also called as a binary regression is also called as. But what is the basic funda? What we need to remember here is that, so that is the two types of the variables will be there. This is called as dependent and independent variables will be there. Okay. Okay, so this is the two types of the variables will be there. Okay, so there's it can be utilized the what you call as, please this is the strength of the relation between, not only what is the first is that, so there are one point is that one is a dependent and another is independent. Independent is also called as explanatory variable. What does that mean? It means that explanatory variable is trying to make the impact on how much it is making the impact on the dependent variable. How much the independent variable IDV. So independent variable is making an impact on the dependent variable, that is called as the strength. How much it is making the impact. Because there are some of the variables may be having more impact or some are less impact. Okay, so for example, consumption and income. So definitely income is having more impact on the consumption also. For some people it will be more, some people will be less. Isn't it? Maybe, for example, maybe the hotter the weather, so maybe it is affecting on the drinking water what we are drinking. So what we drink the water now today, so definitely maybe there is an influence of the weather outside also. So like this is the cause and the relation, this is the one, and second is that strength of the relation between the two variables will be assessed. That is what is called as regression analysis altogether. Okay, and please you stop me anywhere, you want to add to my discussion also, you are very welcome, and you have to have some questions also, we'll take it up. Okay, fine. So this is, and the dependent variables are called as the responsive variables, regressants, and it will be called in a different name also. And the independent variables popularly in the some software is called as explanatory variables also, or maybe regressors also, or manipulating variables. It will be called in a different context and different way. Okay. What to go next? Next. Okay. So these are all the different names. Different names for the dependent variables and the explanatory variables that will be called in the different context. Okay. Now, look at this. This is what the equation I just wrote. Y equal to beta naught plus beta 1 x and E. E is the error term. So we will try to understand this a little more. Then we will go ahead and see what is the discussion.
So my latest PPT is available, sir.
Yeah. Don't worry.
Yes, thank you.
So whatever I use, you can make a note of it also, or you want to ask questions, or maybe at the end you want the PPT.
Yes,
No, don't worry. Okay. So here, so we will try to understand this one is called as okay. So here, what is this? The y equal to beta naught plus beta 1 x plus error term. Here, please try to understand this simple equation use a lot of meanings. Now, this equation looks very simple, but there are a lot of meanings are there. So, the one that what we said, this is called as a dependent variable. Okay. So, this part, this especially the x is called as independent variables, and this is called as interceptor, and this beta 1 is called as a coefficient of, what is called a coefficient of independent variables. It's coefficient of independent variables, and this is called as error term. Okay, this is the what the nomenclature given to an equation. I repeat once again. Why is it dependent variable? Why it is a dependent variable? It is called as a dependent variable because it is dependent on some other variable, that is x in our equation. Okay? Why is it dependent on x? That's why it is a dependent variable, and then x in our equation, it's not dependent on anything. That's why it is called as independent variable, and it is called a regressor also. That means x is making impact on y. So that's why these two terms x and y called as. So y is there are two variables are there. That's why it is also called as a binary variable or binary regression also it is called as, only because there are two variables are there. Okay. So here again I repeat, this is a dependent variable, independent variables, and beta naught or somewhere it is called as alpha also. Okay. Somewhere in some equation sometime it will be used as alpha. Okay. So this is called as an interceptor. And beta 1 or maybe beta 2x2 or beta 3x2, there is beta 1, beta 2, beta 3, if anything is there, they are all called as a coefficient of respective independent variables.
So what actually interceptor?
That is the okay. So this here, if it is beta 1 x1, beta 2 x2, beta 3 x3, here beta 1 or beta 2 or beta 3, whatever the number of variables are the independent variable, every variable will be having its own coefficients. So what is a coefficient? Coefficient is nothing but how much those respective variables, I repeat once again, how much those respective variables are making an impact on what you call as on the dependent variable. So how much respective variables, there may be beta 1x is there, maybe beta 2x2 is there.
Yes.
So that means x1 and x2 are the two independent variables, and they will be having their own coefficients. That is, what is that coefficient? Coefficient is nothing but how much those x1 and x2 are making impact on what you call as dependent variable. And together if it is making, that will make an analysis. Okay, this is what is called as a coefficient is clear. What is the dependent variable is clear. What is independent variable is clear. Okay. Okay, now there are two important terminologies are also there, or maybe things are there. One is called as alpha naught or beta naught. Okay, you can use it simultaneously, maybe you can use alpha also sometime, or maybe beta. Okay, so sometimes beta naught, beta, there is a small difference, we'll understand, but time being we'll try to understand. And before going to that one, this is called as a linear component. Why I'll tell you that. So this is called, we are talking about the linear regression. There are different types of the regressions are there. That also we'll talk now. This is called as the linear component. There are two types of the regressions. One is called linear and non-linear regression. Anything which is going in terms of in the exponential form, if it is not there, that is called as in linear. If it is going in the exponential, maybe for example x square, that's called non-linear in form. Okay. So this is also called as a determinants. Also called as, it is called as determinants. Okay. So we will try to understand what we are doing basically is that we are understanding the regression once again. We are brushing ourselves the regression whatever you have studied in your maybe your coursework or the maybe post graduation also. Okay. So here these two terms, I'll tell you, I repeat once again. So beta 1 is clear, beta 2, x1, x2, y, these things are clear now. Okay, this is, the intercept is also called as slope coefficients also. What do you mean by slope coefficient? The slope coefficients is called as, repeatedly I need a board. Okay, slope coefficients that is talks about always the change, that is called a delta form. This talks about the delta. Or maybe that is the how much the delta, the change in x is making on y. So that is called a slope. Slope is nothing but what? Slope is like this. So that means if you take this is maybe the x, or this is called as delta y, and it is called as delta x. That means how much change in x? The x is changed this much. Due to change in the x in this much, y is changing to this much. That is why it is called as a slope. So the slope is nothing but delta form.
So please once again explain how much?
How much change in this variable? Variable is changing this much. So you understand what is called as slope? Slope is nothing but changing factor.
Ah.
So slope is, it all depends on the how much the curve is going. If it is sloping very steeper, the slope is very high. If it is lesser steeper, for example, if the lesser steeper, it will be different. So that means if there are two variables, so somewhere will be there on this axis, or somewhere will be there on this axis. So slope is nothing but what is they are trying to tell, the diagram is going to tell that whenever you change this factor to some percentage or some, so how much this is making impact on this one. If you take this is an x, if you take this is x and this is y, okay, if you change x by this much, y change by this much. So this portion I am talking about. This is what is called a slope. This is slope. So in this case what happens? Slope will be different altogether. Because here what it tells, so looking at this one, if you are changing x by, this is called as delta x. When you change only this much of x, y is changing this much. That is what is called as your elasticity of demand. We have studied, right?
Yes.
So what does that mean? Impact of change in x on y is higher. Impact of change in x and y is less here.
Yes.
That's what is called as, that is what less elasticity, more elasticity,
Yes.
or different things we have studied. The same things are there. Isn't it, sir? Okay. So this is why it is called as slope coefficient also. Now in the whole econometrics or maybe in econometric equations, the role of these beta naughts and this error term is very high. Many of researchers, we may neglect these terms. We give a very less importance. The whole regression or maybe in this equation, role of these terms is very high. Very much. So any changes in these factors, maybe beta slope coefficients, it will be adjusted here, this alphas or beta naughts. This is also called as, that's why it is called an adjusted factor also. The role of this one is very high. And also the error term. Okay, so what is error term? Or we will discuss one by one. So error term is called as in the unobserved things. Unobserved things. What is unobserved things? For example, let's say for example, consumption may impact on, income may impact on the consumption. That's what we say. It is known to everyone. Whenever my income changes, the consumption changes. But not necessarily the income has to make impact on consumption.
Other factors also.
Other factors are also there. Other things are also, maybe in my model I will not be covering those things. There are maybe 100 reasons are there. My wealth may be the reason, my neighbors are also maybe the reason, or maybe various factors are there, right? Maybe my asset is there, and what is my job I am doing. So many factors will influence my consumption. But in my model, I have taken one thing, that is two things, the income impact on consumption. But other things we are not taken care.
Covered.
So then the error comes, which is also called as residuals. That all be observed or maybe so will be taken care in this error term. That is here the role of statistics or maybe mathematics differs to the econometrics. The econometrics starts from this point. This is that's why we say the econometrics is a combination of statistics and mathematics. And the difference starts from this error term itself. So this random variable, and this is called as error term, that means which is also called as unobserved variables of the things. So that may not be covering, but that manages it. That manages. And this is called as random in nature. Random in nature. Why random in nature? We don't know how much it is making impact. We cannot, that should be random. That shouldn't be perfectly this much is influencing. If your income is impacting on consumption, yes, other things may be also impacting. The other things are random in nature, they may be having fluctuations. So that is why it is called as the random component also it is called as. That is also called as random component because if it is fixed, it is known factor, then it will not be coming here, it will be coming somewhere here. Okay, so the role of this error term or maybe a random component which is also called as residuals, unobserved variables or components, all are taken care in this one. Role of this error term, which is also called as some, in the contextual difference it is different, but standardly it is called as residuals. Residuals. In a general term it is called as a error term. So what is this residual error term? And in a statistical or maybe significance when you are talking about, this is called as white noise also. That will be different when you are talking about the time series analysis. Okay, so the, depending upon the different context we will be having, but standard way this can be called as a residuals, which is an random in nature. Stochastic also it is called as stochastic term. Stochastic because it is random in nature. It is not fixed. If it is fixed and known, exactness is there. If it exists, then it will come here. It will not go there. Are you getting my point? So that is the importance of this error term. Please mind it. Okay. This is one thing. And the next one is called as, what do you call as? We are talking about this beta naught or alpha naught. So now this is called as an intercept term, which is called as intercept term. So what is that intercept is all about? This is in a very, especially when you are talking about the time series, when you are talking about the cross-sectional, more specifically when you are talking about the panel data, the use of this intercept term is very high. So what is intercept all about? Intercept is nothing but the minimum point also it is called as. Minimum point. Or also it is called as, maybe when x is 0, this is a minimum term. When x is 0, that how much it is getting influenced. So, which is also called as, what do you call as, these are all called as this word, it is adjusted terms. Yeah, adjustment with what? It is adjusting with the betas, beta 1, beta 2s and other things. So, here it will be adjusting with this betas, which is also called as, the one word I am trying not to I'm able to, this is called as one word is there. Okay, so I am not able to get. So somewhere it is called betas, beta naughts or alpha naught is called as adjusting factors, also called as.
Also called a constant term.
Constant term is also, but how that constant term comes? It is a constant term. Constant, why it is called as, even x becomes 0 also, this will be the minimum one. Okay, this is called as constant also, or it's called as interceptor. So in a better way to understand, it's called an adjustment factor. Adjustment factor with what? Adjustment factor with the beta 1s and beta 2s. It is making an adjustment with the betas, coefficients of independent variables. Please understand this one. I repeat once again, it is an adjustment factor. It is hypothetical sometime also, by assessed by the regression. It's a, again I repeat, it's an adjustment factor. It is an intercept term. It is a constant term. And it is a hypothetical in nature also sometime. What do you mean by hypothetical or maybe adjustment factor? Hypothetical adjustment factor is nothing but it is getting adjusted with the betas, coefficient of the independent variables. I repeat once again. It is adjusting with the coefficient of the independent variables. That's why the role of this intercept term is very high. Are you getting my point here?
Yes, sir.
So we'll try to prove, or we'll try to discuss that one also. Okay? That's why sometimes in some books we use this one is called as imaginary also. That's why it is called as imaginaries. Imaginary in what sense? Imaginary, that means it will be adjusted with the coefficient of the independent variables. So that is the interceptor. So this is the very brief about your regression equation. So anything you would like to ask, please you can ask. Otherwise, we will go ahead now. Shall we go ahead?
Yes, sir, go ahead.
Okay, fine. Now, okay, these are again two terminologies will come. I'll just tell what is the statistical and deterministic relations. When the exactness, you can read it later also. So, a statistical relation is nothing but a computational relation. When you make a calculation, try to establish a relation is called as statistical relation. Deterministic relation is nothing but when the exactness is high. When your exactness, that means your accuracy is high. Perfectness is high. So that is called the deterministic in nature. Anything for that matter. As your statistical computation or calculation becomes better and better, it becomes the deterministic in nature. I repeat once again. What is the difference between statistical and deterministic? Statistic is nothing but calculated figures. Deterministic is also calculated figure, but it is exact. What is called accuracy is high. For example, if I say that 2 plus 2 equal to 4, that means your accuracy is high, very high. Okay, it happens in the science subject. But in case of social science, this exactness, that accuracy level is little less. Okay, so when statistical relation is nothing but it's a calculated, whatever the relation, F ratio, T ratio, whatever you yesterday you have discussed, all those things comes under the statistical relations. When your relation or statistical significance or the accuracy becomes higher, and that becomes a more deterministic in nature. Are you getting my point? So that means your significant level goes up, that becomes a more deterministic in nature. Okay, so that's why in a regression, y equal to beta naught plus beta 1 x1 error, whatever you say that, this beta naught and beta 1 x is called as statistical relation and also called as deterministic in nature. It becomes more deterministic in nature, or maybe when it is the what is called accuracy level is high. Are you getting my point? So accuracy level is when it is high. So then that means what is the difference between statistical and deterministic is clear. Yes. So maybe we can sometimes we can use it both simultaneously also when your accuracy level is high. Clear? So this is another concept that may be coming a little later also. This is one more example in, I think I have taken from the Damodar Gujarati, which is very, very popular book, everybody knows econometrics. So this is called as a conditional and unconditional mean. It is a simple example. We can go through later also. What is conditional mean? Conditional means, so for example, so these are the different type of the income groups people are there. Okay. So the what do you call as, here there are different income groups people are there. The corresponding to the weekly income of the. Okay. So this is the income level of 80 rupees per month or $80 per month. So how many number of families are there? 55, 60, 65, something it will be there. All together 325 families is having, so what you call as monthly income of 80 rupees or $80 or whatever you can say. Okay. So these are all the number of 325, then you divide, you will get what is called as 65. So this 65 is called as conditional mean. I will repeat once again. Or maybe there is an income group or the people, some families having 100 rupees or $100 and $100 income here. There are some are 65, some are 70. So this 70 numbers, 74, 80, these are the number of families are there. Okay, try to understand this example. This is also going to help us, this concept of conditional and unconditional means, that is going to help us in the when we are discussing about the panel data. Okay, so what we are talking about, this is 80 income group people are there. So monthly income is 80 rupees. Here monthly income is 100, monthly income is 120, so on and so forth. 80 income people, how many are there? 55 families. consumption expenditure 55 rupees, 65, like this. There are different type of the people are there. 80 income group, they are spending like this. So what is their total 325? Okay, divided by number, what you will get? 65. That means this is called as conditional mean. Similar way, this 100 rupees income people, their consumption is like this. And if you divide, and you will get the average is 75.
325 divided by 5, sir.
325 divided by 5 is called as 65. So similarly, 465 divided by this only 1, 2, 3, 4, 5, 6. So that's 77. This is called as conditional mean. Why it is conditional mean? That we try to understand. Why this is called as conditional means? That means we have given this is a 80 rupees is the income, is the condition we have given. This is condition we have derived. These people who are called as 65 average spending people, who are income average is 80. This is the condition is given there. When the condition is given in such way, this is called as conditional mean. Are you clear now?
Yes, sir. Yes, sir.
So thus we are deriving, we are writing some what is condition. Any condition for that matter. It is related to income and consumption. It is there. See, if you are giving one general condition, anything for that matter, if you give that and you will get it, this is called as conditional mean, means average.
Yes.
On some based on some conditions, some criteria, we are going for the mean called as conditional mean.
Yes, sir.
Okay. So if you take, these are all the different families are there, 80, 100, these are all the people are there. So then how many people are there? There is, so 1200, all put together, called as, so if you total of all the families together now,
Yes, sir.
and divided by the number of families. So this is total up. Then there are 80 income group people, 70 are there, 120 are there, 100, all people together. You are not giving any condition there now. Condition is that, so this number of people are there here, so you total up, then divided by number of participants, 32, your average consumption. Then it becomes unconditional. Some may be having more income, some may be having less income. So called as condition, you are not deriving any condition.
Average
by number of people are there. Here average by the number of families here. Here you are not giving any specifying any condition here. It's called as unconditional one. Condition is nothing is there. What is the condition? Number of people are there. But it's called as population, you can also there. We can say that number of people population, that is called as unconditional and conditional. Are you clear now?
Yes.
It is also called as conditional and unconditional. Okay? Shall we go ahead now? Okay. So this is the maybe diagrammatical representation of how the conditional mean comes. So conditional means, for example, this is the average income of the people, the dark one. Average income of the people.
Yes.
And some may be having little high, some may be less, and the average is this one. This is only. See, if you total up all these things, you will get one single average.
Yes, sir.
You will get a, that's called as Y bar. That's Y bar is called as unconditional mean. Okay? So, these things are called as Y caps. That's what I am talking about, the conditional and unconditional mean also. Okay? So, this is called as conditional mean. So, the diagrammatical representation of this one. Okay? Now, this is we have discussed. Quickly again, this is called as about the stochastic term about the error. Okay. So this is also, please, somebody asked in this, what you call as error term is equal to observed values minus expected values. The difference is called as error term. So observed values and expected values. The difference is called as error term. We will discuss again. This is about the error term, the stochastic term, or which is also called a non-systematic, which is also called white noise, which is also called as random. The next one is called as types of regressions, called as linear regression, multiple regression. So linear regression is that which is not non-linear form.
Yes.
Non-linear, we can say that x square or 1 divided by x or 1 divided by square root of x, something like that. If it is all are called as non-linear form. But in we talk about only about the linear regression, which is more of a machine learning or AI as other things will come. So we talk about only on the linear regression. And that too, if it is only two variables are there, one is dependent, independent, it's called as a binary linear regression. If it is more than two are there, it's called as multiple linear regression. Okay, so properties of, okay. Now, so here, in ordinary least square method, try to understand this one. Here, this is the regression line, it's called as. Any regression, when you draw this one, this is the regression line. So what is the regression line is all about? Regression line is called as regression, this line. How it comes? How it comes? How it comes? The regression line. You have studied in your maybe in post graduation. Okay, about the maybe regression line or regression in general. What does it? The regression line is nothing but. Yes, please.
It's a representation of estimated values.
Estimated values
Of dependent variables.
Very good. Okay. So this is the what is called as sir is rightly said, it's called as estimated values. Estimated from what? Estimated from the actual values. I repeat once again. They are the estimated. These are all called as estimated, or different figures are there here. Okay. So this is what is called as regression, which is also called as y cap, which is also called as y cap. So, for example, okay. So here, if you say there is a y, so there are different terms 3, 4, 5, 6, something. These are all called as actual values. Based on this one, you are measuring something. What is called as y caps. This is this is actuals, and this is all called as estimated. It may be coming, for example, 2.99, something like that, or maybe 3.8, or maybe 5.2, something. These are all what is called as estimated. This is called as y caps. Are you clear?
How estimated is come, sir?
That is a regression. It estimates while making this one only. That is a fund of regression line, regression analysis. While making this one only, we are getting beta naught, we are getting betas, we are getting the errors. These are all the things comes when we are doing these things only. These are all the actuals. Based on this one, you are getting the estimated lines.
So what's the reason for that, sir?
That's what. So what you call as, you have different observations. That's why I told about the conditional mean now, unconditional mean. See, here now in our previous example, the income group of 80 people are there, and their consumption is different here. Somebody is 65, somebody is 75, somebody is not there. So what is the average of them? There, here it comes. Okay, so based on these are all the people are there. So one among that one is called as, this is your y cap here.
Y cap.
What is?
Yes.
So like this, there are different people are coming, or variables are coming, observations are coming. So this is your y cap. So while doing this exercise only, you will get all these parameters. Okay, you can say about the forecasting also. When you want to forecast all these things, so these things will be coming. Okay, so this is what is called as your y caps.
That's it.
Okay, so this is what the regression line is all about.
Yes, sir.
So this is what is called as y cap. And for this one, for whole these things, we will be having what is called as y bar will be there. What is y bar? Average, mean of the whole things. So everything will be there. So for this one, please understand here. So we will be having y's also, whereas having the y caps also, we will be having y bar also. Any confusion? What do you mean by y bar and y caps? So y bar is the average of the whole. In the whole regression, one y bar will be there.
Yes, sir.
Are you clear?
Yes, sir.
So here, look at this picture. This regression line, this difference between this maybe this is the y bar line. Y bar is average line, average in the whole equation. Okay, this is the y bar now. So it is fixed.
It's
Okay, so it will be there because it is only one picture.
Yes, sir.
Okay, y bar will be only one, maybe 80 if you say, 90 something like that you say, that will be fixed. So this is the your y bar and this is your what you call as estimated one and this is your maybe what do you say, this difference between this y bar and this is actual y. Okay, so this is your y and this is your y bar. This difference between y minus y bar is called as total sum of squares. Oh, okay. So total sum of square is nothing but this is what is called as your y and y bar. Difference between y and y bar.
Total sum of square.
Total sum of square, TSS. It's called as TSS. What is TSS? This is called as y minus y bars. And it will be always, it will be squared. The reason is that the y is squared, if you don't square it will come 0. We'll discuss that also lastly. Okay, so this is called as total sum of squares. Clear? Now, this is your, this is clear what is TSS? Okay, second one, this is the what you call as then difference between these two, what you call as the actual y's and estimated y's. This is called as RSS. And if you square it out, y minus y caps. This is called as residual sum of squares, RSS. Why we are discussing this point also, there is a purpose for this one. So this is called as RSS. What is RSS? The difference between actuals and the estimated one. Is it clear?
Yes.
This is RSS. And what is called as estimated? What is called as y cap and difference between y cap minus y bar is called as estimated sum of square. If you square it out, it's called as estimated sum of square.
So please show you the how RSS will be going to.
So this is your what you call as y cap.
Okay.
This whole line is your y cap,
Okay, yes, sir.
right? So at this point here some y cap is there.
Yes, sir.
Okay. So the difference between this
Why?
y cap and y bar.
Why bar?
Oh, sorry, y cap and y.
Ah, sir.
Y cap. This is actual y and they are estimated y. Some difference will be there.
Okay.
Difference between estimated and actuals.
Yes,
That is called as residuals. So that is our E.
Yes, sir.
Error.
Error term.
Difference between actuals and what is called as
Estimate.
estimated. That is called as residuals. Residuals. When you square it, is called as RSS. Okay. And then the last one is ESS. Estimated sum of square. What is the estimated sum of square? Y cap minus y bar. Y bar is our average. So different. This is your y cap. This is your y cap, and this is your average.
Total. Okay.
This is y bar. It is, and this is the estimated one. If the difference between these two is called as estimated. When you square it up, you will get estimated sum of squares. And all to put together, TSS equals to RSS plus ESS. This is the purpose of discussion of all these things. To make it very simple, the difference between actuals and average, different. I repeat the whole things just to summarize in one line. Difference between actuals and the average is consist of two factors. One is called a residuals, another one is estimate. I repeat once again, why this whole graph is discussed. The reason is that there are some actual figures are also there, some estimated figures are also there. So they estimate if there is estimated and actual figures, I repeat once again, the difference between actuals and estimated consists of two things. One is called as residuals and other one is called as estimate.
Estimates.
Two things are there.
Yes, sir.
Difference. One is residuals and estimated. Residuals is that part where residuals is that part of actuals, and if this is the line, this is the whole line is your TSS, total sum of squares. Okay. One part is of residuals, other part is of ESS.
Yes. Okay.
Here the purpose of whole discussion is that always the residual part will be as less as possible. If your model is better, if you want to say that your model is better, so RSS part will be less. Residuals should be less. What do you mean by residuals are less? Residuals are less is nothing but that means our prediction is better. What is meant by prediction is better? That means actuals versus the estimated very near.
Very low.
Very low. When they are near, that means residuals are very less. Are you getting my point? I repeat once again. What is the purpose of discussion of the whole this present slide? Present slide to show that whenever we do the regression, there is a possibility to get what as residuals. There is a possibility to get the residuals. Whenever the residual part is less, what do you mean by residual part is less? The error term is less. When the error term is less, the model is more fit. Why it is more fit? It is more fit because the reason is that the difference between what you call as actuals and estimated is less. Because RSS talks about the difference between actuals and estimated. If it is less, model is better. Residuals should be always less. That's how you can read. Interpretation goes like this. See, getting the result is very simple. If you do in Excel also you will get, you do in any software also you will get. But when you understand the model is better, because there are various ways to understand any graph, any table. Okay, doing software will do on its own. Calculation is nothing. Not much is there left now. So this is the fund of the whole discussion. Are you clear? So in a very simple way, in a very simple way, always in a last sentence. Are you clear as of now? In the last sentence to tell here is that always what do you call as this is also should be less.
TSS also
should be less.
Yes, okay.
Why? Rather, TS is nothing but what? Actuals versus average.
Yes, sir.
If actuals and average, say for example, average income of this class is, let's say for example, I take a money income of everybody, average income is 10,000 rupees. Average income is 10,000 rupees. My prediction, my estimation is simply, so then that is what is called as 10,000 rupees. Then I will ask you, what is your income? And you say 9,000. Somebody said 8,500. Somebody, so the difference is near to my average. That means TSS also should be less than.
Yes.
Are you getting my point? Otherwise, but if I say that average income of this class 10,000 rupees, if I go and ask somebody, he says 5,000. Somebody says that 20,000. The difference is very high.
Very high. Yes, sir.
Ultimately is that, so always we have to be near to the prediction. Near to the, actuals.
Actuals.
Prediction should be near to the actual. Because this all relates to what? It relates to next what is called as to find out your model fit, R square value or adjusted R square value. All other things will come. Right? Okay. Fine. Any other questions here? Now we are slightly going to what is called as OLS estimator, ordinary least square. Because so far what we are discussing, these are all related to square only. Again, why do we do square also? Please remember, for example, RSS we were doing square, or TSS we are squaring it. Total sum of square, residual sum of squares, estimate is, here square is coming. Why square is coming? The square without making square,
The zero is.
zero will be there. Because there are some minuses are there, some may be plus, this side plus and this are the minus. If you average it all of them, you will be getting zero. You should get zero. That is a property of your OLS also. That is the property of your OLS also. Okay. So these are all some of the assumptions of OLS. We'll discuss that also. I don't know how much time we have. So how much time now? 11:15 I have to complete. 11:30. 11:30. Yes, good. Okay. So these are all some of the Okay, these are all some of the different assumptions of OLS. We are slightly going ahead with the OLS estimator called ordinary least square method. So we will not go into the much about how the ordinary least square method. So what is ordinary least square method is very important in the regression. It is the beginning of regression also, we say it. So here when it talks about the linear regression, is a linear relationship between the two things called as the linear relation is the one. Then there should exist the additive relation between the dependent and independent variables. What do you mean by additive relations? Additive relation between the IDC, so called DV means dependent variable, and then independent variables refers to the effect of x and y is independent of variables. So what is, please repeat, I think very less number of books will be having this kind of assumptions, especially pick it up this one. Linear you will get heteroscedasticity, this called multipolarity, these are all the assumptions you will be getting anyway. So look at this, this is one of the assumptions, it is hidden one. What do you call as? There should exist the additive relation between the dependent and independent variables. What do you mean by additive relation? Refers to the effect of x and y is independent of other variables. That means, so for example, there are two ways you can read this one. If there are x and x1, there are two variables, x1 and x2 are there. So both are independent. If they are not, they should not be related to each other. And my yesterdays, and another way to make the interpretation is that yesterdays will not be related to with the today's one. Yesterday's consumption should not relate to the today's consumption. So that's what is the relation is called the additive. Okay. The next one is called the multicollinearity. So there should not be any other. The first is no correlation among the independent variables. Independent variables, for example, x1, x2, x3, they are called independent variables. There should not be relation between themselves. So we'll check all these things also. Multicollinearity. The error term should possess the constant variance called as, there should be constant variance leads to heteroscedasticity. The next one is called as, there should not be any autocorrelation. There are all the different assumptions you already studied if you require, but we have to test these things now. We have to test these things. Okay, so these are only some of the assumptions. Okay, the next one. Here, try to understand these are all the different forms of regression we will be getting. Different types of forms called in a general way lean model, log model, log lean model, lean log model. This simple one. What is a lean? Linear. Dependent variables are linear. Independent variables are also linear. Called as lean. That usually what we do. Usually we do on the lean model only. And sometimes we take both the dependent and independent variables. We take the log models, log form also. It's called as log model. Clear? Then there are called as log lean models. If dependent variable is a log model and independent variables are in a linear form, called log lean model. Then the last one is lean log opposite. Dependent variables are linear form and the independent variables are called as non-linear. But when to use these things? Question very easy to understand. Lean log lean is very easy to understand. When to use or how to make the interpretation if they are into lean model or log model. what kind of interpretation can be done? Based on the interpretation, what you required? First of all, please remember, especially when you take the log model of any variables, when you convert in the log, usually to smoothen the data. For various reasons, log will be taken. First of all, please remember. Various reasons. One of the main reason is to smoothen the data, is the main purpose. Second is that there are many measurements are not coincident. For example, somebody is like a very rich person in this class. So he may be earning in terms of crores, and all others we are earning thousands. There is a relation which is like your what do you call as outlier. You say that. So to minimize that one also it will be taken. Second, and the third one is that
extreme value.
Extreme value. Outlier is nothing but extreme values.
Okay.
To minimize, subtract. So when you take the log form of your income, a log form of others are also, then maybe so the standardity will come.
No.
That is called as smoothen data also we call it as. There is the third important reason when we will take the log also. Not necessarily always we have to take log. In such conditions, yes, there are some of the things, or some are in kgs, some are in quintal, some are other things. So in order to make the uniformity of the data also we have to take the log. So like this, in various reasons we'll take. That is not the purpose of discussion here. So what is the purpose of discussion? How if it is a lean model is there. That means both the dependent and independent variables are linear in form. How to make the interpretation of the data, whatever the result we'll get. Okay. So in a regression, for example, what is the regression? You will say that. Okay. So here y equals to maybe beta naught plus beta 1 x1. For example, we say it is a consumption year, and beta naught you are getting something like 8, 9, something like that, or maybe you are getting maybe 7.78, maybe your income. Okay, this is your regression. Now, how to make the interpretation this 0.78? This is your beta 1, right? How to make the interpretation of this one? 0.078 is your coefficient of beta 1. How do you make the interpretation of this? Can anyone? The answer, we have run the equation, we got the result like this. If this is the question and this is the answer, how do you make the interpretation of this one?
1% increase in income.
Huh?
A 1% increase in income.
No.
1% increase in X is going on 0.7.
So here that is the purpose of taking this example and this slide also. When you are taking both the things in a linear form, both the things, they are in unit. If 1 unit of change in X, 1 unit of change in X make an impact on Y, 0.78 units. I repeat once again. When you are talking about the lean form, when you are talking about the lean form, is nothing but what is called as, if 1 unit of change in X will make an impact of 0.7 unit on Y. Are you clear? Yes. This is about the lean form.
So why that's only point for that? 0.78. Why not for minimum or why not for maximum? 0.78 it's a standard?
No. I just hypothetically I have taken that one. Just hypothetically I have taken one. It could be anything. We'll run now. Immediately within 2 minutes we'll run the regression now. Okay? So how to make the interpretation I am talking about? Okay? When you have the lean model here. Is that clear now?
Yes, sir.
So the next one is called a log model. What do you mean log model? Log model is that both the dependent and independent variables are in a logarithm form. You have taken the natural logs. Okay? So here the interpretation is the same thing. Result maybe you are getting this way only. You may be getting 0.78 also, anything you may get. But that is in a percentage. 0.70 is 1 unit change in your X, 78% of your Y is getting affected. Are you getting my point?
Yes, sir. Yes, sir.
If you are changing of 1 unit of X, 78% of your Y is getting affected. That's the word. It's called a log model. Are you getting my point?
Yes, sir.
So that means whenever you are talking about the log, it talks about what is called as percentage. That is you have to be understand. And it continues whenever the log comes. Most of the time it is in the percentage.
Percentage.
Without log, if you are taking, that is called a unit form. So this helps you make the interpretation in the days to come. Because depending upon to smoothen the data, to get the better result, we are making a lot of exercise. Lot of permutation, combination, taking, deviation, log model difference, we have lag models, we make the lags, we take the logs, we take the first difference, all kind of exercise will be done. But the interpretation of the result is a little different. Okay, so similarly what is called as, here also, if it is what is called a log lean model. So here log lean model, what is happening? Percentage.
Changes in 1 unit of X.
1 unit,
Of X.
20% changes. It is a different here. Here, what is called as beta 1 into 100. What is called as into 100 you have to make it.
Yes.
Into 100 you have to make. So that is, it is in a simple way. Whenever the log coming, it's called as a way of interpretation. This comes in the percentage. Clear?
Yes.
So it continues. That's the reason. Okay. Okay. Then the next one. So I was a little slow now. This is one more. Quickly, we will understand this equation. So there are different types of equations are there. Maybe you can have a look. Quickly, I'll read also for you people. That is called a static model, dynamic model, auto-regression model, distributed lag model, ARDR model, first difference model, different types of models. I quickly tell you that. So because these are all the things that are going to help us in the panel data. So here, yt equal to alpha plus beta 1 plus xt. This is called a static model. It is a static model. Why it is static model? Static model is that. So this is how to make the static model. What do you mean by static model? This is called as today's income or this year income or this year thing is affecting this time only. It's called a static model. I repeat once again. If it is a time series, this stands for the time series data. That is, this period income or whatever the variable is affecting only this period is called as static model. If anything t minus 1 is coming, this all are called as a dynamic models. That means previous year income. Maybe income I am taking repeatedly because of common example. Okay, previous variables, previous independent variable or previous income for that matter is making impact today. If it is continuous, that is called as a dynamic model. So what is that? Here it's nothing but t minus 1. So this is t minus 1 is what previous thing is affecting on the present one. It's called as a dynamic, anything for that matter. So this is called as a dynamic. Then what do you mean by autoregressive? Autoregressive means if the dependent variables, if you are taking the lag of that form is called as autoregressive. I repeat once again. What do you call as autoregressive? Autoregressive. It is getting regressed by itself. It is getting, for example, here you take, this is autoregressive. So what is there here? Yt, this is a constant term plus beta 1, yt minus 1, yt minus 2. So what do you mean by here? That means here also y's are only there. Yes. But it is a lag form. It is t minus 1, it is t minus 2. This 1 period lag, this 2 period lag. Lag means what? Previous values. Yesterday's income is affecting on the today's consumption. Day of yesterday's income is affecting on today's t minus 2 it is. So that is called as autoregressive in nature. Then what do you call as distributed lag. So distributed lag model is that, so you take this. What is the difference between this one? Distributed lag model. This is called as a distributed lag model. Why distributed lag model? That means here you are taking the today's impact, today's income impact. Now we are talking about income consumption. So today's income is effect on today also, yesterday's income also today's consumption, day after yesterday's income on today's consumption. So all called as distributed. You are distributing the regression. It's called a distributed lag model. You are taking the lag also and distributing the impact. Impact is yesterday's today. Day after yesterday's today. So this is called a distributed lag model. Are you getting my point? So the combination of auto-regression is called a ARDL, auto-regressive distributed lag model. Here t x t minus 1, y t minus 1, both are coming here. See, t minus 1 and y t minus 1.
Yes, sir.
So independent variables lag models are also there. Dependent variable lag models are also there. Here this is called as auto-regressive part. This is called as a distributed lag part. So both are combination in the one equation, that is called as auto-regressive ARDL model, called as auto-regressive distributed lag model. So what do you mean by here? What do you mean by here? When you go to the higher side, we are not going to the discussion that one, I am just giving the glimpse of that one. So what do you call as distributed lag model, auto-regressive, that means it is getting graced by itself, is called auto-regressive. Distributed means independent variables, their lag models. Lag means, please understand, that is the previous values. So that is called ARDL model. The last one, very important one for our panel data, called as first difference model. What is first difference model? First difference model is that, look at here, the last one. It's the first difference. So there is a lot of, there is a difference between lag model and first difference. First difference is yt minus t minus 1. Yt minus t minus 1. So, say for example, if you take this one, so if you take this one, so this is y, okay, you have 2, 3, 4, something you will be having. Okay, this is yt, right?
Yes, sir.
So, here yt minus 1. So, here yt minus the difference between these two. That means yt minus 1, what is that? So, yt minus 1, here 2, here 4, or maybe here 5, it will come. So, here 3, 4, 5, it will come like this, right? This is t minus 1.
Yes, sir.
Difference between these two, I repeat once again, this is t minus 1. This previous period is coming here.
Sir.
This previous period is coming here.
Yes, sir.
And difference between these two, let's for example, here difference is 2. Difference is here 1. Difference here 1 again. This is yt minus 1 it is. This column. This is called a first difference. So look at here, if you are getting confused here, look at here, yt t minus 1. So yt's are there, today's income
Yes, sir.
and yesterday's income. Difference between yesterday's income, today's income is called the first difference. And here, your today's consumption and yesterday's consumption, difference between yesterday's consumption and today's consumption is called as this. Xt minus t minus, this is called as first difference. This is the one of the method, what you call as, in your panel data it will be there. Okay, this is about the some of the things in the, what you call as, in your regression. Okay, so we'll take quickly this one. Okay. So these are all some of the points when you run any OLS. There are different things. First, we have to look into the what you call overall significance, then significance of the individual variables, and then we have to look into the R square, adjusted R square, and also we have to check about the assumption also. Okay, you have another 10 to 15 minutes, right? So we'll quickly run whatever we have discussed so far. We'll try to run in a greater now. Okay.
Yes.
So open your greater now. Just open the Gradle, since time is very less. I'll just run through now. Open your Gradle. Are you following me, or can I change now? Actually, I am starting. So, what is late? Are you okay now? Yes, okay. So, you open. What is the data set? Okay, we'll take FER2. FER2 now. Okay, now open, you know how to open the data, this one, data, yeah? So I'll tell you first thing, maybe for my reason I'll do this one. I'll go to preference. You don't go there because I try to increase the size. For visibility purpose, I just increase the size of the, now it is visible to all of you. Okay, go to the file, then go to the open data.
So, sir, go to the file.
File, open data, then user file, click on it. Wherever you have that your folder where you are saved, no, go to that floor. User file, I have in my E drive. Open file. Even you can drag it also to your Gradle directly, but sometimes it gives error. Please don't do that. Open file, then user file, then go to your folder. You're done? Done? Any problem? Yeah, where you have saved that one? FER2. FER2. It's not visible now? Ah, that's the reason. The reason is, are you,
Is it better to change it to Excel, sir?
ah, that's the reason. At the down here, you now it is an Excel form, right? XLX form. Here there is XLX form. Go to this one.
Sir, wait, sir. I just open it.
Yeah. Okay, go to this XLX here, XLX, because there is an XLX form, right? You done?
Is it CSV file, sir? Because if you are, it's not detecting, sir.
XLX file, it is visible.
XLX.
XLX also you can say. This one. Now it is visible, right? Then go to the FER, select that one, say open. Select this one, say open. Open. Now this window is appearing. Okay? Don't do anything directly, you can go what you call as. So maybe okay. Import. This means column, rows, it is asking. Don't do anything, it will its own. You have done this one?
Yes, sir.
Any problem there?
We're downloading, sir. We're downloading the file, sir.
You still are not taken from your WhatsApp?
Yes, sir. Yes, sir. That's the reason, sir. Just.
Next.
Anybody is having problem? Done? Okay. Now we have to do run OLS. And why we are discussing OLS, why we are discussing the regression is that panel data is another extension of OLS model itself. Panel data is another extension of OLS model itself. That's why we are giving more importance to this OLS model in simple way regression also. You are done? Go to model, then ordinary least pair, click on the ordinary least pair. So the window will be pop up now. Okay. FER is a DB, that is a dependent variable. Select and take it to here. Select and take it to here. Done? Then whatever you take one first, any one you can take. CPI, what do you call it? FER is nothing but your foreign exchange reserve. Foreign exchange reserve, then CPI and exchange rate it is. CPI index is, you know what is CPI index. ER stands for
It's open. Then after this 3, 5, then what we have to do, sir?
Open to Gretel. Go to Gretel. So take anyone first. Anyone. I have taken CPI, right? Then say OK. You are done up to this stage?
Yes, sir.
Okay, then say OK directly. Don't do anything. The window now it is here. CPI 1, you take first. Anyone you take rather than that matter.
So then,
Done?
yes, sir.
So this result you got it?
Yes, sir.
Okay. So once you get the result like this, so what are the points to remember that I told you? Maybe in the slide I have not gone through detail. Now I will do that one. First, whenever you will get any regression output, first you have to click into 2-3 important points. First, very important is that your F statistics. F statistics P value. This is your F statistics P value. Whether it is more than 0.05 or less than 0.05. That is, you want to say that is it significant or not. The first very important thing to check is this model fitness. Some people say this is R square also, but I prefer this is a very important one. The reason why I tell you, sometime in a model you will get a better R square, but sometime your model is not significant also. That is the reason I repeatedly tell that please look into the P value of F statistics. Is it significant or not? Okay, so here this is called as overall significance of the model. It is called as point number 1. Point number 1, the overall significance of the model has to be checked with the F statistics P value. And where is this? Here, this is the F statistics P value it is. So what is the null hypothesis? Null hypothesis, model is not fit. Write it down, no problem. Model is not fit. Idhar result badal rahe elrado?
Yes, sir. Yes, sir.
So null hypothesis is model is not fit. Okay, first null hypothesis, model is not fit. Now you have to check whether P value is more than 0.05 or less than 0.05. If your P value is less than 0.05, then your model, that means what to do? Now your model is significant. So it is less than 0.05. Your P value is less than 0.05. Do you agree for this? It is the value is less than 0.05. Do you agree?
No, sir, it's a 7.54, sir.
No, that is the reason I'll tell you that minus 26. That means it is nothing but, what is that? I purposely am always asking you. This is, it is how it will be read in Excel, and here also it comes like that. So here it will be 0.00026 times 0 it is. Then 754 it comes like that. It's nothing but 0.05, less than 0.05 itself. 26 zeros you have to write.
6 zeros.
26 zeros you have to write here. That is minus signal. In Excel also you will get a result like this.
Yes, sir.
That is, that number of zeros are coming after decimal. Then definitely it is less than 0.05.
Yes, sir. Yes, sir.
Right? So now do you agree for it is less than 0.05?
Yes.
So model is significant or not? It is significant. That means your null hypothesis accepted or rejected? Rejected. Your rejected null hypothesis, that means model is fit. Do you understand this one? Are you clear? So this is very important one. Then immediately if you want to have a look on the individual significance also, this is called as individual significance. This is the P value of T statistics. This is a T value. P value of T statistics. This is F value of, sorry, P value of F statistics.
Okay.
This is for overall significance of the whole model.
Whole model.
This is the significance of the individual variables. This is what for it is? This is for what?
Significance of the individual.
Individual variables of what? CPI. Individual variables. Any number of variables you may be having. Then that variable, whether for example, sometimes you will be having 3-4 variables. Some may be significant, some may not be significant. Then you have to make some trial and error there. You can drop there, you can add there, you can change some things. That we can do it later. Now here is this case also. This is also significant, and naturally both are same here because we have only one. Because we have only then T statistics and F statistic value will be same. Because the independent variable is only one. Overall significance, that is F and T, both are one and the same here. Do you agree for this?
Yes, sir.
So that's the reason the whole thing is significant here. But the problem is, are you clear now? What is P value of F and P value of T? P value of T for the individual significance of the variable and F for the overall significance of the model. Done? Anybody is having doubt? Now, next thing is that you can also think of what is called as R square. R square. Here, it is here the R square. Usually, the pattern is that, so R square value ranges from 0 to 1. That means 0 to 100%. So, as it goes towards the 100%, it is a better fit model, we can say. So, what does that mean? How to read this one? Here, first of all, how to read? It says 0.67 point something is there.
67.7%.
I'll take it as 68% roughly.
Yes, sir. Yes,
Okay, 68%. That means you are independent through the help of independent factor, that is CPI. You could able to explain the dependent factor by 68%. Are you getting my point? How to read this one? That means how to read your dependent factor can be explained by the independent factor by 68%. That is the value of R square. Right? Are you clear? But we need better and better. Sometime we get a better R square. Sometimes 98% also we get, 99% also get. But please think, many people make a mistake. R square is better, so model is best. Many students say like this. Please don't do that mistake. If you say that some R square is 98% is good, no problem. But at the same time, please check this P value of the F statistics also. If both are significant, the overall model is fit. Then you go to this individual variable, whether it's significant or not also. Are you getting my point? So then you can say the overall model is fit now. Okay. Are you clear? So here this is the standard error and all these things are there, and now I will not go to that one. So one more thing. So Durbin-Watson test is there. So before going to the Durbin-Watson, I will tell you one more is that adjusted R square is that. So adjusted R square is it talks about the related to the degree of freedom. Please make a note of it. R square increases as your number of variables increases, but adjusted R square will come down. I repeat once again. R square increases as the number of independent variables are increasing. R square increases as the number of independent variables are increasing, but adjusted R square it decreases. What do you mean by this? What do you mean by this means adjusted R square talks about the degree of freedom of the variables. What do you mean by degree of freedom? Are you following me or not?
Yes, sir. Yes, sir. Yes, sir.
What do you mean by degree of freedom? How much freedom will be having? See, in this classroom, somebody is coming inside. There are 32 participants. You are there. Somebody first time he entered. He is having all the chairs are. His degree of freedom is more to him. He can sit anywhere, right?
Anyway, yes.
He or she can sit anywhere. If the second person comes and he will be having less number of one chairs. One chair has gone. Degree of, so that means when the more variables, when the third person comes, already two chairs are occupied. He will be having less two already occupied. Degree of freedom is reduced. That the adjusted R square talks about. Adjusted R square, as the number of independent variables are increasing, degree of freedom comes down.
Yeah, after model, we will looking for a degree of freedom if you go to minimum or maximum.
No. Always it should be maximum. But we have to read the adjusted R square. See, how to read? Are you following me or not? Difference between R square and adjusted R square. See, now I have taken CPI is the one.
Yes, sir.
I'll add some other variable also. Please to improve the R square. R square is only 67%. Now I want a little better. I want to make it 80, 90, something like that. Some related variable I'll add. So to improvise. But when by taking one or another two independent variable, whether R square will increase, there is no doubt R square will increase. But look at how much adjusted R square will increase. So what does it mean? Adjusted R square, how much it increases? Nothing but. So the difference between that, now it is 67 or
Yes, sir.
percent is adjusted R square.
Yes.
I'll add one more. So by increasing that one, adjusted R square, how much it is increased? 61 to 70 there. That means additional factor is influencing in your model only that percentage only. Are you getting my point?
Yes, sir.
Please understand the R square and adjusted R square. Rule of adjusted R square is very important. Many of us in the research paper we neglect that. Role of adjusted R square is very high. We always talk about the R square only. Role of adjusted R square is also important. Okay, so we'll look. Then there's one more thing is that what is called as Durbin-Watson test, which is used for the autocorrelation factor. Autocorrelation between what? Autocorrelation between
Combination of the static and dynamic.
No. Auto-regressive that we are talking about. Autocorrelation. That means autocorrelation is related to what? Error term. Error terms are correlated each other. Error terms, E factor what? Okay, so here Durbin-Watson test result, if it is 2, it is best no autocorrelation. The result is if it is 2, no autocorrelation. But it is a standard format. If it is between 1 to 3 also, it is taken as a better one. 2 is the best. Nearing 2 is the best one. But if it is falling in some of the literature, please refer the literature also, some of the review of the your records. Between 1 to 3 is also somewhat acceptable. But if it is nearing 2, it's always better. That means there is no autocorrelation. That is, relation between the error term is 0. It should not be there. Are you getting my point?
Yes.
What is Durbin-Watson test? 2 or nearing 2 or 1 to 3 is much better. So how to improve upon this one? There are various methods are there. Maybe one of the method is that take the other related variables. This is one method. So many methods. Now I'll take just purposely I left the one of the variable. That's another variable is there in the model now. Do this. So we have taken only CPI.
Yes, sir.
There's a exchange rate is another one. Is that try to take that one. We'll see what happens. Go to the model, ordinary least square. Then dependent variable is FER. Then you take both the things together. That is called as this CPI and ER. Take it to the. So already constant is there here. Okay. These are all the regressor means independent variables. Say okay now. Look at both the tables now. No, nothing is improved. Durbin-Watson is still gone worst level. R square is improved some extent, but still not work. Okay. So this is the one of the method. Now here also what you can do is that, so this is again there are various methods. Now we have to check what you call as some of the assumptions of the OLS model. What are the assumptions of the OL model? What are the, one is called as the mean of error term should be 0. That is the one of the assumption.
Yes, sir.
There are 2-3 important assumptions there. We'll check, then we'll drop here. Okay, we have to check the assumptions of the what you call as OLS model. One of the this one mean of the error term should be 0. That is I told also. So how to check the mean of the error term? So to check the mean of the error term, see, go to the save, any of the model, better to take any one of the model. I will take the model number 2 only, because both the variables are there. Still Durbin or there is a autocorrelation problem is there. We'll see how it can be rectified also. Okay, first thing is that, go to the, what do you call as, go to the save.
Yes, sir.
Go to the residuals. Residuals is called as a error term.
Yes.
Click on the residuals. This window will get a pop-up. Right? Say anything, you name it anything or you can name it. So residual may be 1. Okay, say okay. So look at your model. Now one more additional variables which was not there earlier. What I done? Go to save, then go to the residuals, click on the residuals, the window will pop up. You can name anything for whatever you want. Say OK. When you say OK, I named it as RES, this is a residual. The new variable is appearing on this one.
Yes, sir.
So click on this one, you will get to know these are all called as residuals. That is the E part of your regression. Last part of your regression is E. Click on that one, you will get this. This is your residuals. Are you clear? This is your residuals. Now what is the assumption is that this should mean of this one, it should be 0.
0, sir.
0, correct?
Yes, sir.
So right click on this one, select the residual, right click on this one, you go to any of this one, there are so many factors are there. See, before I could have told you that also, I'll tell you now at last. There are a lot of things can be done, graph also you can get. So now we are talking about the assumptions. See here, right click on this one. Are you following me?
Yes, sir.
Okay, so here right click, you take with the summary of the statistics, click on this one, you will get this. So the mean is average. That is 11 zeros are there, 0.11 times zeros.
Yes,
Is
sir.
it nothing but 0 only?
No, sir.
So one of the assumption is fulfilled. Done? Okay. The second one is the error term has to be normally distributed. Because why it is normally distributed? The reason is that should be random in nature. It should not be connected to each other. You should not have a special thing in that one. You should normal. Extremely high, extremely low, or should not be there. You should be normally distributed. Okay?
Yes, sir.
So to check that one, click on this. Okay, variable normality. See what I did, I selected this one, selected variable, then normality test. This is normality test. Click on this one. Here there are so many tests are appearing. We'll take this one, Jarko-Bera test,
Yes, sir.
which is the test standard used for the what do you call as to test the normality of the variable. If it is less than 0.05, we can say that it is normally distributed. If it is not normally, the question may be appearing in your mind. If it is not normally distributed, you have to make the correction in your variables, or you can drop the whole discussion. Or else you have to make what kind of a corrections? You can add new variables, or make the first difference, take the log form, various permutation combination you can do it also. Otherwise, if it is still not improving, you have to drop it. Somewhere data is wrong, dependent variable is wrong, variable is wrong, or data itself is wrong also. Okay, so this is significant. Second important thing. Third important thing is that there should be, are you clear so far? Any questions here? Okay. So the next one, there should be homoscedasticity. Then equal variance of the error term, equal spread, normality, and both are both are one and the same almost. So here, if you go to this one, where is that? Okay. So here, test. Okay, sorry. Heteroscedasticity. Okay, we have to check the homoscedasticity. That means error term should be this means homoscedasticity. That is almost like error should be equally spread. Equally spread. So to check that one, go to the test, then heteroscedasticity. There are various tests, white tests. There are so many tests. Here, Brosh-Pagan test is the very popular one to test the homoscedasticity or heteroscedasticity. Opposite is heteroscedasticity. If it is not homoscedasticity, it is a heteroscedasticity. That not equally spread. So click on this one, you will get this. This is the p value. P value. No, it's not less than 0.05, it is more than 0. Please.
More than
We are checking the heteroscedasticity. Please understand. Test is heteroscedasticity test. That means there is homoscedasticity. That means now.
heteroscedasticity.
No. It is homoscedasticity. Opposite. We are checking the heteroscedasticity. If the p value is more than 0.05, then you are not rejecting the null hypothesis. We are checking not homoscedasticity, heteroscedasticity you are checking. Here the result is more than 0.05.
Yes, sir.
So here what is called as, if it is not solved, there are so many other things are there. So this is another way Brosh-Pagan test for the heteroscedasticity. Okay. Then next one. There should not be multicollinearity is another one. And before that one, very important, what you call as autocorrelation. Autocorrelation. So to check this autocorrelation, there is there. No, we need not to check. It is already, there is a presence of autocorrelation. There is a problem with the model. We can do many exercises here. We can take the first difference. We can take the log form.
Yes.
So check in what form it goes. Let's say for example, I'll go to anything, trial and error it is. Okay, go to model, ordinary least square, and this is our independent variable. There are the two or our dependent variables which are already there. Now click on this lags.
Yes, sir. Wait, sir. So wait, sir.
Same thing again. Now I am checking the lag. You can make the first difference also. If it is coming not with the lag form also, then we have to go for first difference. I told you what is the lag form. It is how to do in Gretel. I am telling you. Because of the reason, autocorrelation problem is there in the model.
So we go to the file. Then what?
Go to the file. This window is clear.
Yes.
No, I'm not clear, sir. There.
Here. Now go to the model.
Wait. Okay.
Ordinary least square.
Okay.
Then select your dependent variable. It is very simple. Gretel is very easy to use.
Just
and it is a free one also. Same thing SPSS does. Same thing SPSS, but we pay it is for that one. It's a very free one.
Select.
Select and drag it. Done, sir? Okay. Now, after doing this one, go to here, there is the lags. Go to lags.
Yes, sir.
Click on this one. Now this window will pop up.
Yes.
Now do whatever you want. You want the lag of only dependent variable or you want the lag of all these things, you can do it. Now we'll check only first. Immediately don't go for it. We'll go for the lag of dependent variable. Here you want 1 lag, 2 lag, 3 lag. That means t minus 1 or t minus 2 you want. What do you want? So now I'll say that t minus 1 only. What I am doing? For dependent variable, 1 lag I am taking. So just take the 1 lag. Now it is appearing here. If we are dependent variable, 1 lag. It is appearing as a one of the independent variable now. It was not there earlier. Now run. Now run. Look at here. Your Durbin Watson test.
Less than 2, sir.
Less than 2, but much better. Much better, much better. That's what I told you. Between 1 and 3 also accepted. If sometime you won't get, try to get the set 2 lag. If not getting, go to first difference. I'll tell you in the next exercise how to do first difference also I'll tell you. Now autocorrelation problem some extent is solved now. Exact 2 it's not possible to get in a practical life. It's not possible at all. If you get it, I think you are luckiest person. Because the reason I'll tell you reason also why exact 2 will invent it. Whenever you having the time series data, autocorrelation problem is very heavy. Because what is happening? My yesterday's income is affecting my today's consumption.
Yes, sir.
There obviously it is. If I am rich yesterday, I am eating better today. Naturally there is a connection between yesterday and today.
Today, yes.
Quite natural.
Quite natural.
But we cannot say that we have to go ahead like that. But you have to resolve some extent, not 100%, at least some extent. Resolve and go ahead. How much effect is there? We need to check. Then we go ahead. Yes, somebody is asking some question. Any questions here?
So if we take lag 2, then it's coming 6.25.
6 point.
25. Durbin Watson test.
I think it is 2. I think it is going out of more than 4. It is going. That's what we have to check all these things. Should be between 0 to 4 only. If it is going out of that means second lag is not making any influence here. Now we also check. Now I'll do that also. I don't know whether I'll get it that one. So see. Okay, before I forget, what is the one more speciality of the Gretel I'll tell you. Please remember, all of you. Because we manually type there the equations, model what we will get. See, this is the model what we get. So how to write this one? See, go to this file, you view it as an equation. So this is the equation, directly you can take it. This is, directly you can take. What is your slope, what is your constant, what is your coefficient, everything is there. Just copy paste also you can. This is one more beauty of this Gretel. Because usually you do it manually. Now you can just click on that one. Where I gone? Go to file, then view as equation. Now this is what you are getting. How many variables are there? How many r? What is r square? What is your equation? This is your equation. Everything is here. Is it not easy? But I have seen some people, some in the research thesis also, the whole chart is printed. I'm sorry to say, my department only whole chart is printed. It's not the way. Here, whatever is required, you have to take and make analysis and write the interpretation of that one. Everything is not necessary. Okay. So they are written this Akai criterion and other things. So usually these other criteria, these are all for to check the model fit only. Nothing wrong. But what is that? Usually those kind of things will come the non-linear regressions. Okay, not now. So this is the one. And second, see, I'll go to the modify. This is another way to do that one. See, these are all so many things are there. You will get it. See what before I could have told all those things. So you can get this frequency distribution, density plot, box plot, QQ plot, all these things we can get. Time series plot. So usually, for example, you have called a box plot. Usually, this is to check the outliers. If there is no outliers here, if sometime we may be having some outliers. So when you keep doing, see, this is your QQ plot. This is your QQ plot. This is called as a regression, and this is our actuals. Right? So many things are there. Then we will go to the unit root testing later. Time series plot. This is the graph what we get in Excel. Everything's ready. Need not to type. Directly you will get all these things. Then one more you can say that, for example, frequency distribution. See, don't do anything. This is frequency distribution against the normal distribution. See, this is another way to check your normality also. Almost except some of all your variable is normally distributed. I am checking about the CPM. You take about your independent variable. The dependent variable. Frequency. This is another way to check that thing. Test against the normality distribution. Except this is one, almost your data is normally distributed. Anything, any questions? Any questions you have? Huh? Sir, Sidhu sir, wait ಮಾಡಕತ್ತಾರ. ಅಲ್ಲ ಸ್ಟಾರ್ಟಿಂಗ್ ಸ್ವಲ್ಪ ಅವಸರಲೇ ಬಂದ್ರಿ ಅದು ಟೇಕ್ ಆಫ್ ಆಗಲಿಲ್ಲ. Anything? Okay? So we'll have whatever the time as early as possible, please come back. We have a lot to do now. Okay? Thank you. Rohit sir. Okay.
That is good.
In our situation, in my case, some variable is dependent variable. In your case, that may be independent variable.
That may be possible.
Yeah, that is possible. Situation and objectives, what you will be having, what you are talking about, what is your review of literature, what is the purpose, so what the methodology they have used,
Yes, sir.
what is IDVs and DVs they have taken,
Yes, sir.
what is their assessment, how they have made interpretation, so what tools they have used. These are all what we do. Literature review is so important, but it is a neglected form actually. We just read the only conclusion abstract and we'll report
Yes,
it.
yes,
No,
sir.
it's not like that actually. We have to read it very carefully. What is the purpose of making study? See, here in economics, we know that price is going to impact on demand.
Yes, sir.
Demand is also making impact on price also.
Yes, sir. Yes.
That is also we know it.
Yes, sir.
What context we are talking about is a difference.
Different.
Nothing, so you cannot say that this is a dependent variable, dependent variable. It is the contextual form and the literature what you suppose.
Yes.
Okay, quickly, you have any questions in the morning session? I'll just wrap up in 5 minutes. First, whenever we run any OLS, ordinary least square, which is a very important part of your regression. Okay, so first of all, once you run anything on any software for that matter, why I have chosen Gretel is because it's a free software, very free, and you can and easy to use. And some of the commands are very easy here compared to any other software I have seen. And you will have better software than this also. It's not necessarily that we don't have any software. We have better than this one also. Okay. But here it is a very easy to use for any econometrics purpose. Actually, R is the best one we say. It's a very syntax form. A small mistake also gives. When you do analysis at the last, you do any small mistake, the whole analysis goes down. So that's unless until we have command on that one. Here, small mistakes will be taken care.
Yes, sir.
So that's not. And whenever since you asked the data related question,
Yes.
when we use any data, background work is very important. Cleaning the data, missing the values. So all these things we have to work out background. Once you say that it is ready to use, then you have to do it.
Yes, sir.
Before eating the food, we have to make all that preparation.
Yes, sir,
Everything
yes.
is very clear. We do it very cleaning, very meticulously. The taste of the food is better. The same way it comes in. That is very important one. Okay. So when you run that one, overall significance we have to check. Okay, first, and then R square, adjusted R square. Here I repeat, R square always increases, adjusted R square may comes down. It tells about the degrees of freedom. And as you take the additional variables, R square will increase, adjusted R square may decrease. When it decreases, then you have to decide. So how much additional variable is explaining the dependent variable. Okay. And lot of permutation combination we need to do. I used in the morning many number of times this sentence. Why? Because now I taken CPI as the independent variable in the beginning. Now we can check in the other way also. What is that? See, instead of CPI is one, take another one, the exchange rate. ER is a independent variable, then check. Okay, and together you can check all three things together, which is the better result you will get. CPI, independent variable. ER, single independent variable. Together another independent variable. So, sometimes I will tell you, adjusted R square especially, sometime, I read once again, sometime, individually it explains better than when in combination. And sometimes in combination it explains better than the individually. So like that, what combination of variable we take as an independent variable is very important. For that one, literature should support. Our background of the study should support. So when you do all this kind of exercise, you will get to know many of the things. Okay. So then what you call as p value of f, p value of t, r square, adjusted r square, Durbin-Watson. Then you have to talk about the satisfaction of the OLS assumptions. More specifically, 5 assumptions, especially 2, 3 are important. One is called as error term should be, mean of error term should be 0. That is, should be there. If not, maybe question may be coming in your mind. If not, what to do? So if not means you have to make changes here. Either maybe you can add one more variable, relevant variable, or maybe you take the log form, or maybe lag form, or maybe first difference. So all that you need to do, which is a better result. You need to be able to justify that one. Okay, justification is very important. Simply keep on doing this. What is the purpose you are doing? Purpose of doing that. Okay, and after that one, maybe you can check about your normal distribution of the error term. Most of the time, error term should be check all assumptions. Most of the assumptions of the OLS is related to error term only, except one which is related to multicollinearity, which is related to the multicollinearity problem. Multicollinearity should not be there. What do you mean by multicollinearity? Multicollinearity means independent variables should be independent. If they are related, that's called as multicollinearity problem comes. That means there are x1 and x2 are the two independent variables. They should not be correlated. Both are independent together. For example, the yesterday's my income and the today's hot weather. Both are independent. Should be independent. If both are connected each other, then they itself behaving together. So then influence on the dependent variable becomes different one. And one more point I forget to tell. The Durbin-Watson test, it should come to 2 also, is one of the best model. But in case of autocorrelation testing. But if it is 1 to 3 is always better. Or third condition also we say, in some literature, whenever you read books, you will get to know that sometime and not all the time, depending upon the contextual form and the situation. R square value is lesser than the Durbin-Watson is better. I'll repeat once again. R square value should not be more than the DW value. Okay, this is also one more point you have to take into consideration. R square, not all the, again, it's not a generalized word I am using, but most of the time. R square value should not be more than Durbin-Watson result. If it is more, it is called as spurious regression. Spurious regression. What do you mean by spurious regression? Though R square value is 98%, 97 better, but your Durbin-Watson is giving around 30% something which is much lesser than 1. Okay, in our case what has happened? Durbin-Watson is 67 and 70%. So what we say that 70% of our independent variable is explaining the dependent variable. But Durbin-Watson is only 15%, 10% it is there. That means your independent variable, there is a correlation between T and T minus 1. Yesterday's income, today's income is correlated. Today's income is related to then tomorrow's income. And myself, I am correlated myself, then making assessment of dependent variable is not at all possible. That becomes called as spurious regression also. I repeat once again, it's not standard, but it is one of the very important spurious regression. By Mr. L.A., he has given this concept called as spurious regression. Though R square value is high, Durbin-Watson is less. In other way, if R square is more than Durbin-Watson, there is a possibility of spurious regression. So, it's better to say that Durbin-Watson should be better, more than the R square. Very good, remember. This is another way to say that model is best or not. So ultimately what we are doing all together, assumptions in whatever is. So purpose of doing is that we need a best model. What do you mean by best model? That independent variable should be able to explain better the dependent variable. My income should be able to explain my consumption better way. That is what we want. So that is our regression is all about. That should happen. That's why in a regression, this concept of intercept term and the error plays a very, very vital role, I said in the beginning. Plays very, very vital role. Because this intercept term do the adjustment factor, error term is the unobserved things will take. It gives a clean form of beta 1, beta 2, beta 3s. If these two things are correct, automatically beta 1, beta 2, whatever it is, better. That's why we check. If I should be better, my environment should be better. My culture should be better. If that is better, that is beta naught and error term. If it is better, my coefficients are also better. My behavior is better. Are you getting my point? This is why it is like that. Okay? So this is what we say about. Okay? Now, we'll start with the panel data today. Now, okay. So panel data, I think I don't want to take much time. Quickly we'll revise. What is panel data? You all studied, I think. Definitely. It's a combination of cross-sectional and time series data. Okay. So what is time series data? Time series data is nothing but where is your variables are in the different time periods. It may be minutes, it may be days, or it may be weeks, it may be years. If your variables are going in terms of what is called as in terms of the time is going. So for example, my income, this last month, next month, whatever it is, these are all going in terms of what is called as time. Time it going accordingly, changing accordingly, or studying in terms of time is a factor. This is called time series. What is cross-sectional data? Same time period, but different entities. Entities will be different. The different entities it will be there. For example, today, what is your income, my income? So we are a number of people are there, but we are checking today. Time period may be today, or this year, or this month. So what is your income? What is her income? What is somebody's income? So all this one, at one point of time we discuss it called as cross-functional data. When you combine both the things, called as a panel data. When here time is also there, and different entities are also there. Different entities, variable number 1, variable 2, variable 3, different time periods of different countries also. If it is there, that is called as a panel data. Okay. So this is what we say. This is a combination of cross-sectional and the what is called as time series data is called as a panel data. Okay, and please here and there I may be a little speed more. You can stop me also whenever you need any questions you can ask, or you can add to my discussion also. Okay. So panel data is a set of what is called as here. Please kindly note whenever writing the panel data, usually it comes like XTIT and YTIT. Here, usual notation of writing the panel data, I stands for the cross-sectional, T stands for the time. If you say like this, it's called as a panel data is nothing but. It is time factor is also there of different entities. So, here maybe, so for example, sorry. So, the purpose of writing this panel data, when you say that YIT equals to beta naught plus beta 1 XIT plus error term IT. This is what is called as panel data. If it is simple time series data, usually you write XYT beta naught plus T. This is time series data. Simple cross-sectional data, usually we write, it's like this, sorry, XI plus EI. This is a combination. This is your cross-sectional data. This is time series data. This is your this is panel data. Sorry, panel data. This is your cross-sectional data. Way of writing. Looking at the equation itself, this is your panel data. It is because here I stands for the cross-sectional, T stands for the time series. Okay, so that's why this is called as a panel data. Okay. Now, here the panel data is a set of XITs and YITs, where XIT is the exogenous variables, which is called independent variables, and YITs are the endogenous variables. Okay. Now, so why panel data? What is the importance of panel data first of all? Panel data is usually used or better to use because the information is more. Information is more. What do you mean by information is more? In time series data, as you all know, it is different time period of time of one entity. Indian income or GDP of India from 1950 to 2025. So you can say we are studying about only one country, maybe 100 years also no problem, 50 years, 20 years. So the information is related to one entity. Okay. But whereas in the panel data, that's why is that panel data helps in the control. Yeah, I'll come to that one. And the next, what is called is a more informative in nature, or more information is there. The reason is that there is a combination of, for example, if I take India's income between what you call as 2000 to 2025, that means 15 years income of India is studied. If I say SAARC countries, how many SAARC countries are there? If I'm right, 11. 11 if I'm right. SAARC countries. Or you can take BRICS. BRICS is the 5 countries are there, as the name itself indicates. 5 countries are there. In BRICS, what do you call it? Britain or maybe Russia. Russia, if you take, Russia's income maybe last 10 years, last 20 years you can say. But if I am studying about the BRICS, 5 countries of the last 10 years, 5 into 10, that is 50, data is of 50 times. If I take Russia for only 10 times, only 10 units are there. So information is more in case of panel data. Are you getting my point? Information is obviously more because entities are more, time period is also more. Right? So that panel data plays a very, very important role in making some research analysis because the information is more. More the information, better the paper, better the result it is. In that way it can go. Why panel data is used? Because usually when we say that better the paper or better the result, when you are using more information. More information is possible in the panel data because it is combination of both cross-sectional and the time series data. When all the things are together are there, then the information is more. Are you clear? More the information, your paper or your research will be better. Okay. The next one is called as.
If you during the research paper, whether we go for the panel cross-sectional data or time series.
No, it's don't go by any standard. I need only cross-sectional data, time series data. It depends on the objectives. What objectives we are set? I want to study. So I want to study about the what do you call as income of the people or the health awareness of the people in or maybe health conditions of the Dharwad people. So here then objectives is related to one entity.
Health conditions.
Then health conditions of Dharwad. So then if you go for the cross-sectional, it's better. Okay, but when you want to study that how their income is, maybe the age, the maybe living standard is increasing, then time series is better. So what is the objective, purpose? That is important one. But since I am talking about this is, I am talking about my child is a better, I used to say. It's like that. Okay, so for in other way, the panel data information is more obviously because information is more. That's simple. Then one more is that we call as panel data also helps in controlling the individual unobserved heterogeneity. So what is meant by heterogeneity first of all? What do you mean by heterogeneity means? Let's take the example of the BRICS itself. brings 5 countries. 5 countries are having the different intercept, different constant factors in a, if you talk in a econometrics term, Russia is saying different, Britain is saying different,
GDP
everybody is, so they have their own interceptor because the GDP is depending on their conditions. So that is all observed. The individual unobserved heterogeneity is observed in the called as panel data. Right? So that will be studied of different entities. Different entities, things will be studied at one point of time. That is the beauty of panel data. That's why this is one more important thing about the panel data. So that called as controlling the heterogeneity. Heterogeneity means different entities are there. Since different entities are there, for example, 5 people are there. Your behavior is different, my behavior is different, his behavior is different, her behavior is different. That all together you study it, what it means, you are trying to pull it, try to control, try to say. So you are trying to study all the 5 people at one basket. Sometimes you put on the 5 people are there, you are, whether all 3 people are better, or 4 people are better, or 5 people are better, or a single is better. All these things you will try to study in the panel data. That means you individual unobserved heterogeneity you are trying to study in the panel data. That is another importance of the what you call the studying the heterogeneity is possible, and that means
extreme values also we are going to study.
That is extreme values. Now you coming. That is a beta knots, alpha knots. That is what is called as adjustable factors. Since morning I am trying to tell. That all comes into this one. Adjustable factors. Your behavior is different, his behavior, everybody's behavior. Try to control in this constant term. Constant term will get adjusted with the adjusted. When it is adjusted, and then your beta 1 and beta 2 are better.
Okay. Adjustable factors.
Trying to make it homogeneity. Trying to make not homogeneity, but it's trying to make like that. Are you getting my point?
Yes, sir.
So that is the panel data. Thus here, since morning we were talking about the error term, now we are talking more focus on the intercept term. That is related to heterogeneity and homogeneity. Right? And these are all the other importances are all there. Construct the test, more complicated behavior can be observed. Larger degrees of freedom. What do you mean larger degree of freedom? More information will be there. Okay. So this is the model of what you call as panel data. That's what I said in this one. Okay. So this is the model of what you call as panel data. I's are there and T's are also there. So which represents I for the cross and T for the time series. Okay. There are the different coefficients that beta 1, beta 2 are these different coefficients. This is the error term. Error term, then it's both cross sectional. So together we are studying. Is that clear?
So, but actually research, when you're looking for the normalities, somebody will say that the sample size should be at the normalities.
I could not get your question.
With respect to the evaluation process, the all behavior should be at homogeneities, not for heterogeneities. If it is heterogeneities, maybe result will be going to changes.
No. Normality is different and homogeneities are both different, sir. Normal behavior is different and homogeneous behavior is different. Homogeneous is that I and you are same. I and he are same. It is called homogeneous. You are totally different, I am totally different, called heterogeneous. Okay. Normality is my behavior is normal. I am saying that by spending 1 rupee, I am taking the better utilization of 1 rupee. That's my normal behavior. I am throwing 1 rupee outside. That's I am not normally behaving. Getting my point? There is a lot of difference in homogeneity versus the normality. My behavior is normal. That's it. In economics, with the rational behavior. What is the purpose of rational behavior? Every penny will be counted and taken the utilization. It's called normal behavior is called as. Statistical term is called normal behavior. In economics term is called as rational behavior. That's it. So it's not the odd behavior. Whenever the people drunkard, no, they are not a normal behavior. They have not behavior. What they speak also they don't know. What they be also they don't know. It's called as not normal behavior. Abnormal, it's not a better word. You can say that not normally behaving. Your data also should normally behave. You want to predict better. You want to say that better results. Otherwise, you have to make it normal. That's why in time series, maybe in the afternoon you have that session sir was telling about the time series. The first and foremost thing is that you have to make the data stationary. Stationary is that you can be able to predict the result better. Otherwise, it is going the way it want, then the prediction will be not scientific. So the maybe sir, madam will be talking to you. Okay. So again, in the panel data, different types are there. Balanced and unbalanced panel data, or maybe short and long panel. Okay. What is the balanced panel data? If each cross-sectional unit has the same number of time of observations. That means cross-sectional data and time series data are one and the same. And each unit, for example, I am talking about India. India for 10 years, or maybe another country, that is also for 10 years. So that's called panels. See, this is for 11 years, mine is 10 years, that's called unbalanced.
Yes.
Clear?
Yes.
So that is good. Then one more comes the short panel and the long panel. What is short panel here is that here time period t is smaller than the n. That means t's are more than the what you call as n's. T's are more than the time period is more than the n's. Usually most of the time in economics we talk about the more of short panels. Your time period will be 10 years, 20 years, 30 years, but n's are very less, or maybe 3 or 4 or 1 or 2 or something like that. So short panel, but that's called a short panel, and called as a long panel, which the number of n's are more than the time period. Time period is only for 5 years. Maybe you are taking 6 or 7 or n variables. So that's called as the long panel. Are you clear? These are the different type of the balanced and unbalanced short and long panel in big cortex. Any doubt here? Okay. Now, okay. Now, before going, I will go to in the reverse way to now. Morning I'll go from what do you call as panel data itself. Just morning we had taken law at end of the session. I'll go in the reverse way now. Now open. I'll show you the Excel sheet first. Then we will go for Gradle. So this is your data set.
Yes, sir.
Panel data set. So what is there? So how many number of firms are there? Number of firms are 10. Number of firms. Some 1, 2, 3 number is given. Different type of firms. You can say countries also. Firms
Yes.
or countries or industries, you can name. There are 10 firms or 10 countries are there. A given number. This one. Is it clear?
Yes, sir.
And the time period. That is 1935 to how much it is there? 1935 to 1954. That means how much? 20? Yes, 20 years. Time period is 20. Time period is 20. And the number of firms how much are? 10. So is it short panel, long panel?
It's a long panel. No. Here is more.
First one, T is more than the N. N are 10. Time is 20.
20.
It's a short panel.
Short
Most
panel.
of the time in economics we talks about the short panels. Okay, now let's say there are 3 different variables are there. Investment, it is the capital stock and value. Okay, so these are all the different, this is how the data is there like this. Okay, just have a look on this one. Okay, nothing is missing. And whenever you want to use, before that one, cleaning, looking, missing values, it's very must. Okay. Now, you go to the Gradle now. You go to Gradle. Go to Gradle. Can you able to say the last person here? Can you able to see? Should I increase? Okay. Now, before going to this one, I could be able to say that in a panel data, there are three important methods are there. What I said in the morning also, now also I am repeating, panel data is the extension of your OLS, continuation of OLS. Only thing is that you are playing with intercept term, constant term, adjustable factor, that is plays a vital role. Why adjustable factor? Why intercept term? Because it has to be adjusted with the all cross-sectional entities. Are you getting my point now? So it has to adjust. That's what I said in the morning, it's the adjustable factor. There's one more word is that I could not able to remember that word. So, but in a simple way you can say that it's hypothetical or adjustable factor. Now it plays a vital role because it needs to be adjusted with the other all cross-sectional units, entities. Okay, so that's why I say that OLS, panel is a just extension of OLS itself. Okay, so what is this? First one is pooled OLS. What is meant by pooled OLS? It's a OLS method only. You are the pooling the data of more than one cross-sectional unit you are pooling. Pooling of what? Pooling of constant term only. I'll tell you what is that. How to make the interpretation. So that is a pool of OLS only. But you are pooling the data of cross-sectional units. What you are pooling? Your constant term also. You are trying to say that maybe there are 4 people or there are 4 countries are there. All 4 countries having the same constant term. That is called as poolable. I say that all 4 people have the same constant term. Adjustable factor for all the 4 are same. Are you getting my point? That is called as poolable. When that case, pooled OLS is used. If all 4 people or 10 people have different intercept term, then we have to go for the fixed effect model. If you cross-sectional, I'll repeat once again, if the cross-sectional units have different constant term, which is simply it can be said, if it is not poolable. Poolable means all cross-sectional units have the constant same term. Then we have to use the pool OLS only. How to use? Same OLS as we used. But we are combining the whole cross-sectional unit into one. If it is poolable. If it is poolable, it's nothing but all cross-sectional unit have the same intercept term. Same intercept means what? All adjustment factor is same. Are you getting my point?
All adjustment factors will be same also.
And a simple word I am using. That's not the technical word. Technical word is that intercept term is same. Technical better word is that poolable is same. Poolable. That's why it is called a pooled OLS. If not poolable, if not single intercept term, then go to the fixed effect model. Under fixed effect model, we have called as LSTV and then we have called as first difference. What is LSTV? Least square dummy variable. Fixed effect is nothing but least square dummy variable. What is least square dummy variable? We'll check in greater. We'll try to make interpretation. What is that? It is does here is that we are giving a dummy variables so that we can create the different intercept for the each cross-sectional unit. I repeat once again. What do you call as fixed effect is nothing but LSTV. Here what is called least square dummy variable. What is called by least square dummy variable or fixed effect model is nothing but you are trying to give dummy variable to others. If there are 5 cross-sectional units, for first unit 1, others 0. That's what dummy variables to be given. So like that, why it is given? What is in order to give the freedom of what you call as give different intercept to each entities. Are you getting my point? When you run that one, you will try to get that. Okay. So if that is not also, Now you can check with the first difference. So first difference, no much difference between the fixed effect model, LSTB and fixed difference is one and the same. And there is one more method called as first difference under fixed. First difference is that, I'll tell you the first difference how it is will be used. First difference is that you are taking the first difference of the variables. So based on that one you are trying to check. Why you are doing? In order to control the first one, heterogeneity. That for that one you are doing. Here if it is things are not working, here if it is not working in pooled ALS, then coming to fixed one. Here things are not working as per your expected, then you are going for the random effect model. What is the random effect model? Here in the first one, intercept term is same. In the second one is intercept term we are trying to give different one to different. In the random effect model, what is that? Intercepting is random, we don't know. It will be taken on its own. You are not giving any command, it takes on its own. Whatever is comes is a random effect model, it happens. Are you getting my point? Okay. So now, we'll try to go with this and okay. Come to this Gretel now.
For understanding something, so if 1 minute is missing, it's a whole concept.
Shall we go to the Gretel now?
Yes, yes.
Okay. Now, open the data, user file. If anybody is not following, please let me know. User file. Then go to the folder wherever you have saved that one. Again, don't forget, this is XLX. Many times what happens, we go this one, you click, now nowhere my Excel file is showing here.
So open.
Open. Then here, XLX, whichever the form you have. Sometimes when you download usually government documents, usually they are in the CSV files. CSV files. Majority of the time we will be getting XLX file only. CSV files are there, then you have to convert this as CXV files. Okay. Then there are some text TXT formats are also there. That is also there. Okay, you can whatever the extension form of the data you will be having, that will be using. Okay. Now, where is my? So the panel, this click on this one, say open. Click on this the data panel, 10 into 20, 10 entities and 20 time series. Click on OK. Don't go. Is this window pop up now?
Opening new data file will be automatically closed for current one.
Yes, yes. If you are not closed the earlier one, it automatically the earlier will close on its own. Otherwise, if you want, you have to save.
Yes.
If you are not saved, it will be deleted. Okay. Earlier, any work you have done, no. If you are opening the new one, earlier exhaust. Otherwise, if you want the same one, you have to save it.
Save it.
Or copy paste, whatever the way you have to save somewhere. Otherwise, automatically it will. So, is this window is popped up now?
Yes.
Yes, sir.
Now, what we are opening? We are opening the panel data. Okay. In this panel data, say the column row is okay. Say okay. Now, what is here? Look at here. The imported data have been interpreted as undated cross-sectional. Do you want to give the data as a time series or panel interpretation? Yes.
Yes.
Okay, now, structure of the data set. You want to be read as a cross-sectional or time series or a panel data?
Panel data.
Please understand, by default you click cross-sectional time series data, it will read the only time series only or cross-sectional only. Now since it is in the panel data already purposely I opened the Excel file earlier to show you that one. It is in a stacked form. What do you mean by stacked form? One entity first, second entity second, third entity like. It's called a stacked form. Okay. Then we say it's a panel, right? Then we go to forward. Now, Now, please, the one more, panel data organization, how do you want? Here, stacked time series, stacked cross-sectional, use index numbers. Now, here also, if you know exactly each cross-sectional unit, number of periods, number of n and number of t's, then you go for the any of the above things. Exactly. If you have 10 entities, all 10 entities, how many time period and how many firms are there, if you know exactness, then you go for this one. Otherwise, if you ask to read the software it's on your own, go for the index variables. Sometimes you may make a mistake. So you go for this one, say forward. Now, group index number for time index number is here, obviously, and forward. Now, data is in terms of what? Annual it is there. Okay, so whatever the annual data, it will read accordingly. Same. Its starting point is same.
Yes, sir.
35 correct?
Yes, sir.
Sometime it may mistake, you are just small things you need to check. Okay, parent data, stacked time series, stacked 1. That means 1 period after that one, stacked I told you. 10 cross-sectional unit observed for 20 periods. Correct? So the data time dimension is 1935 to 1954. Everything is fine. Anything is there, you can go back also. Now this is ready. Last okay. Panel data is unlike OLS, here importation of panel data is, you need to small observations. In case of simple cross-sectional or simple time series data, extracting the data is much easier. But in panel data, we have to make in a greater, we have to be very cautious.
Very well.
Because whole interpretation goes wrong. The reason is that you give any command, it will give some output. Because it reads numbers. When it's read numbers, it will give some output. And based on that output, you are writing something, then automatically everything is wrong. That's why we need to be a little careful. That's it. Not much. Okay. Now after this one, what we say? So we have 3 different methods. What is called a pooled OLS, fixed steppered, and random field. Okay. First of all, before going into the pooled OLS method, we need to check the poolability. If the poolability is there, then only the pooled OLS can be done. I repeat once again, poolability is nothing but pooled OLS only. Now we have to check whether it is poolable or not. What poolable? Intercept poolable. What do you mean by intercept poolable? Can you take the same intercept to all the entities? Are you getting my point?
Yes, sir. Yes, sir.
Can you take the same intercept to all the cross-sectional units? If it is yes, then it is a poolable. If it is poolable, then need not to worry about the fixed or about the random.
Yes, sir.
You can don't worry, don't go ahead also. That means OLS only, nothing more than that. If your data, when you are doing research paper, if your data is not poolable, same intercept term is not accepting, then you can go for the next one and next one, like that. Wherever you are getting the better results, you stop there. Need not to go ahead here. Right? So now in this one, to do this one, so poolability check, we have to do this. Okay? So data is poolable. Now what we are doing, we are checking the poolability. Okay? How about the go to model, okay, model, okay, now this panel is visible now, look at it. Earlier in the OLS, when we were applying in the morning, in the first session, that was not visible.
Yes, sir.
Now it is visible, okay, this panel. Now, we are not going for the method, we are just checking the poolability here, okay. Now, fixed, see, panel data, fixed or random effect is there. Click on this one. What is your dependent variable? Investment is a dependent variable. Then you take value of these two are your independent variables. Independent variables. You are done?
So wait a second. Which one first one?
DV, purposely I have written DV so that you cannot mistake. So DV is a dependent variable, other two value and capital stock are the your independent variables. Have you done?
Yes, sir.
Okay. Now we are not going for any method, we are just checking the whether pullable or not. We want the P value. So what is our null hypothesis? Null hypothesis H0 is data is pullable. H0 is data is pullable, which is nothing but data is having common intercept term. That is your H0. Now check the P value of the model and whether you have to accept or reject, you have to decide. Are you getting my point? Now what we are doing, we are checking the whether data can be pullable. That's the reason H0, the null hypothesis is data is pullable or cross-sectional unit is having the common intercept, one and the same. So to check then we are doing this. The same method is there for us. So say okay, the result is here. Result is here. Result is here. So don't read all these things. We'll go later on this. Come to the last one. Here, this part.
Differing group intercept.
Here, test for different group intercept. What is null hypothesis? Groups have the common intercept. What is your null hypothesis? Null hypothesis is data is pullable or common intercept. So what is your P value? P value is less than 0.05. H0 is rejected. Rejected. H0 is rejected. Because it is less than 0.05. What do you mean by rejected? That means there is no common intercept. That there is no common pullable. Data is not pullable. That means pooled OLS cannot be done. Are you getting my point?
Yes, sir.
Pooled OLS cannot be done. But if it is insignificant. If it is more than 0.05,
Then it is
pullable. You have to stop at the pooled OLS only. No need to go for the next method. Are you clear? Now since your null hypothesis is rejected, null hypothesis is that data is pullable, which is rejected. That means fails to accept. Fails to accept or rejected, one and the same. So that means data is not pullable. When data is not pullable, no common intercept term. So that means whatever the cross-sectional unit 10 you have, they may be having different content. Maybe 2 are same, or maybe 8 are same, 9 are same, 1 may be different also, we don't know. If 1 is different also, it shows like that. Or 10 may be different also, it shows like that. But definitely common intercept is not there. Okay, this also you can report in your research paper or your thesis. You can report in your thesis. Are you okay?
Yes, sir.
Shall I go ahead?
That means we don't take as a the 0.05 is there. We will compare this one, but generally we will not go to 8.70015.
No. Minus 45.
Okay, that is not a.
45 zeros are there.
Minus 45 means 45 zeros.
Yes, minus 45 means minus 0.45 zeros.
That is an.
No. If it is, here these are all are like that only. Since you are asking this one, I will tell you, this is 42 zeros here. This is also significant. This is also significant. 3 stars. This is more significant, it's nothing but. 2 stars, 1 star. This also you can report. Star also you can report in your thesis. Many softwares will give this stars. Star 3 star is the best one. That means more significant it is. Without your thinking, you can take that value. Okay. So now we are talking about only this. It's not beta. It's not pullable. Fine.
Yes.
Now, by chance, you may be getting data is pullable. Many of the times, panel data pullable, it is very less. But there is a possibility, we cannot say. We are studying about the income behavior of this area and the area of the Hubli people. Maybe common intercept, possibly you may get. There is no much heterogeneity group between the Hubli and Dharwad. Behavior may be the same. Maybe climate condition is same. Possibility the same pullability you may get. Depends on the topic you are studying. Objectives you will be having. Maybe you will get in that case, just I show you. So what to be done here? Now again, here you are running the only OLS only. I repeat once again. By chance, if it is pullable, if you get the debt, so here we don't have that.
Yes, sir.
If it is pullable, directly you are going OLS only, which we have done in the morning. Same OLS only. That's what pooled OLS. Look at here. Take this one. Then investment is a dependent variable. Then your value and capital stock are already it is there. Value and capital stock are your independent variable. Then you simply say it's a pooled OLS. I have done nothing. Same OLS method only. I repeat once again, but actually not to be done.
Yes, sir. Yes,
Because it's not pullable.
Yes, sir.
But I am showing you the only steps. What is that? Here you don't do any panel data here. Not required. It's not a panel data altogether. Since all 10 entities have the common intercept term.
Yes, sir.
It is starting point is same for everybody.
Okay.
Starting point of whatever you say, that is same. At least very nearest of the near, which is negligible part of it. So that means don't go for any panel. It directly can go for model OLS, ordinary least square method. Then your dependent variable, whatever it is there, and whatever the independent variables are there, then say okay. That itself says that you are doing OLS. Again, interpretation is same. Interpretation is that what is called as what is your R square, what is P value of the F. Okay, this is you will report in the newspaper, this article or maybe this is. Then you are talking about the R square here, 81, which is much better. The adjusted R square is also 81, still good. Okay, now, so this things and individual significance level is also better. So value, this is also 3 stars, or we can say about the 0.05, less than 0.05. Even capital stock is also less than 0.05. Please read, don't 1 point. It is that number of zeros here.
Yes, sir.
Clear?
Yes,
So like this, so whole unit is better. But again, there is a problem with the Durbin-Watson here in this case. There is a problem of autocorrelation here. Here also you can check the residuals, normality. So how to do that one? So look at here, residual, you can do even residual plotting also you can do it. See, you want to check. This is not actually, this morning I am repeating here. So look at here. So residuals you take anything you say about residuals. See, this residual is coming here. Then summary statistics. This is also mean of the square. You are checking the what do you call as the
Mean.
assumptions.
Mean
of the error term should be 0. That is 0. It is here. So normal distribution also you can check what we have done in the normal distribution. So what we have done in the normal distribution here in the morning?
We go for
Normality test.
jargon based test.
So same, again you have to check all these things. Why I am telling these things, only thing I am repeating here. Check, if not satisfied, you have to make corrections there. But one underlying factor, there are certain things in panel data you can ignore. The reason is that different entities at a time you are studying. There is a problem of what you call as heterogeneity, endogeneity problem. At the end I will come to that point. There is a possibility all the OLS assumptions cannot be satisfied 100%. But we are trying to improve to the extent possible. We can improve. Otherwise, you have to lose. Now look at whether autocorrelation is there here. Autocorrelation, can it be improved? Look at here whether can it be improved. Just check whether can it be done. I'm just randomly thinking here. See, look at it, it's improved again. It's improved. Durbin Orson is earlier word, how much it was there? 0.20. When I have taken the lag value of your dependent variable. How we have done lag value of the dependent variable? I repeat once again. So here edit, modify, then everything is selected, go to lags, lag of the dependent variable here, then one lag I have taken, say OK, now this is what the result. I am not taking this one, just I am giving the steps here. Your Durbin Orson is improved. How it is improved? By taking the log value of the dependent variable. That means some extent your autocorrelation problem is taken care.
That means log is more power, sir.
Not more power. See, it's not question of the not log, lag. Log, it's not powerful. In the log I said in the morning, to make your data little smoother, log is taken. Lag is taken when you are trying to say that in your data, previous thing is affecting today and today's thing is affecting tomorrow. If your data says that not yesterday's, day for yesterday is also affecting today, means you have to take 2 lakh.
2 lakhs.
If you are thinking that yesterday's is affecting today, you will take 1 lakh.
How it is predicting, sir? How it is?
Again, literature. Think of that. For example, maybe FDI. FDI, it comes to India, the lag effect is usually high. Because coming and executing using by the people here takes time.
Yes, sir.
But our own income, for example, I am taking money from somebody and using and investing, getting, it takes little time. But if I have money, I invest and get the benefit, the effect is more. So your money effect on me takes little time. I have to come and maybe you are a banker, I have to apply, get it. So lag term is little high. Again, I say the literature, you have to support the different data, you need to think about it. Impact of that one, maybe some people made the analysis of that one. But in case of, for example, stock market, then no second impact will be there. Lag is almost zero. Stock market.
Why, sir?
Stock market.
Why?
Because the behavior is so sensitive. Within no time, the effect will be there. Small changes anywhere in the world, it is making impact today.
Then what? How we will do?
No lag value. Lag value is you have to try to avoid that. There you have to improve the variables. Take the more variables. Or you have to improve a number of years. Variables, either cross-sectional unity you have to increase or the time series units you have to increase. Whichever fits better, you can think of it. In such cases, because that's the reason, what is your topic? What is your literature? Their lag doesn't work at all. 0 hour it happens. Zero time. Almost in 0 time the effect will be there.
Yes, sir.
So then the lag doesn't work there. So in such cases, even though your lag value you take and result you improved, then your thesis or maybe research For number it looks nice.
Nice, but it's
But your background of the study is something else. I can question, how do you take the lag value of that one? Since your result, impact and incident right now only, impact which is happening, impact and incidence is distance is there, then you take the lag value.
as your experience also you for the doing the
Not experience is one, another one is that you have to take the literature, that is very important. Lot of people, maybe government has given the result or maybe experts spoke on that,
yes sir.
it's like that.
Yes sir. Thank you.
Okay.
Yes sir.
Okay. Okay, so for any other questions please? About the polability test and pooled OLS. Two things we have spoke here. How to check the polability? If it is polability is there, then run the OLS, make the interpretation.
Interpretations.
And check the OLS assumptions. Then if it is any problem there, you have to correct it.
Right.
Whatever the problem.
Yes sir.
Error should be zero, normally distribution, heteroscedasticity problem, multicollinearity, autocorrelation. These are the four things need to check. If, that's what again, so I'll repeat, some of the problems may be ignored. We'll come to that end. Some of the problem can be ignored in panel data. Or if it is not satisfied much, can be ignored. In panel data only. If it is time series or cross-sectional, cannot be. Okay. Pooled OLS. Then we are coming to what you call as fixed effect model. Fixed effect model. Here what is happening? Fixed effect method allows the heterogeneity, that is individually all among all the cross-sectional units by allowing to have its own intercept term. That's what I said. In the beginning I said, in fixed effect model, what is that? What is trying to do? It is allowing to have each independent variable its own intercept term. Each cross-sectional unit is trying to have its own, trying to give
It's one.
intercept. But it is called a fixed. Why it is fixed called? It is a time invariant. What do you mean by time invariant? For entire time period, it is fixed. Same. Entire time period, it is fixed. 1935 to 1954 time period, the entire the intercept is same. That's why it is called as fixed
Effect model.
fixed effect model. I repeat once again. Though it is trying to give a different intercept to each cross-sectional unit. I repeat once again. Each cross-sectional trying to give a different intercept. But it is called a fixed because it is time invariant. What do you mean by time invariant means for entire time period the intercept term will be the same. That is called as fixed effect model. Or you also call as LSTV, what do you call it? Least square dummy variant. Okay. How much time? One. We are coming. Okay. Okay. Now, before going to all these things, what to do with it? Fixed effect model within estimator. Actually, I need to tell this one also.
So what actually sir? Show that. What actually shows that? So
You just have a look. If you could not able to understand, just have a look for a minute. Here, in the fixed effect model, it runs on the within deviation. Fixed effect model is also called as within deviation model also. What is within deviation? Within deviation is this. How do you get this? Look at here. T, this is just a hypothetical example. There are three firms. There are three firms. 1, 2, 3. Time period, maybe 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, this is a balance panel data, you can say. So individual mean, that is called variables. XIT is a variable, right? So that is 9, 10, 11. That is for one firm. Second one is 20, 20, 20. And third firm 25, 35, 35. Then individual mean is that 3 the 9 plus 10 plus 11, that is the individual mean.
Ah, sir.
Okay, mean of that firm.
Okay.
That is called an individual mean of the firm 1. Second, that is 20, 20, 20, that is the mean of the second firm.
Second firm.
30, 30 is mean of the third firm.
Third firm.
So overall means all together. This morning I said no, conditional mean, unconditional mean like that. It's first one you can say the conditional mean. Second one is called as unconditional.
Unconditional.
So what is that? All together, how many are 3 plus 9? That means, so variables all 9 divided by, all 9, that is summation of 9 divided by 9. That is called in overall mean it is. So how do you get this? Overall mean, that is all the variable divided by number of observations. That is 9, overall mean you will get.
Okay.
So that is maybe 20, the 20 for common to everybody. That is our y bar you can say. In the morning case, it's a y bar you can say.
Yes, sir.
So like this, so the overall deviation is that xit, then overall mean. What is the deviation? Deviation means overall deviation. You can say TSS this,
Yes, sir. TSS.
like that, TSS like that you can say. This is your original value, xit.
Exactly.
X bar is that average of your values. Overall mean. Then what is called as between the deviation. Between the deviation means what is called as this and this.
Between the
Between the mean. The within the deviation. What is the within deviation? This xit minus x bar I. This one. This is the fixed effect model runs on this. Fixed effect model runs on this. That is the purpose of showing this one. Or LSDV. One more, in while writing also, here this alpha I it is there, alpha 0 is not there. Alpha 0 indicates it is a common intercept with a poolable one. When you say that alpha I or beta I, it represents that different intercept term. Thus sometime when you go to the very micro level, this also counts a lot. If you use not common, if you use I, it's called as different intercept with different cross-sectionality. Right? Now, we'll run the next one. Before doing that one, see, now we have to do the different intercept term now. Now what we have to do? Okay. So different intercept term to all these things. Now go to add, not the phone one. Go to add. See, go to add, select the variable, independent variables, select the independent variables, go to add, unit dummies, click on that, add unit dummies,
Yes, sir.
unit dummies. Look at here, what is happened here? What happened here? So dummies are created. So what is the dummies talks about? Double click on that one, you'll get to know. Any, there are 10 companies, 10 cross-sectional unit, you click on any of these ones. This is the unit dummies. For there is first company, first time period. First company, second time period. For all that one, it is 1. For remaining things is 0.
0.
That is dummies. Go to second one. Second one is like that. So first it is 0. Second company, first year, that is dummies. Otherwise for everything is 0.
Yes, sir.
Clear?
Yes.
Now here what we do, panel data, fixed equal. Now oh sorry. Is it dummy create my dummy is created for what?
Value demo.
Value dummies?
Value demo create.
Now what we have done? I repeat, go to model, ordinary least square, then your dependent variable, whatever the dummies you are created, select all the dummies, go to here. I'll tell you what I have done, again OLS only. Here panel data, if you do, there is a question of the dummy trap is coming. Look at here. What is happening? One is left out here. The 9 companies, out of 9 companies, there are 10 companies, 9 is taken here. When 10 out of 10, look at here, I will do that one also. When you go for the panel data, see, look at here, this is panel data, fixed equivalent. So it's not showing the omitted due to exact collinearity. So see. So because of that reason, what I have done is that model, I am running ordinary least square only. Again everything is same. Then say okay. So you get this. What is here? Quickly. Here what is happening? So there is 9 companies. Company 1, 2, 3, 4, 9. For the 10th company, it is the interceptor. Are you getting my point? What is this intercept? This itself is what is called as your beta knots. Or in a better way, you can say the beta i's, not beta knots. Because for each company you have different intercept. Are you getting my point? So now we can check the what is called as, see your p value here also.
Yes, sir.
Less than 0.05. And also you can check about the your p value of the t statistics, which is significant for all these things. Up to here it is significant. For all this company it is significant. But the question is that it's not significant here. You have to say that effect of these companies on your dependent variable is less. But this is significant means these are more effective. Wherever you are getting significant result, you are the more effective here. So what we have done is that we have done that different intercept term is created here also. Okay? So again, interpretation, everything is same. We'll not go to that one. What is your Durbin-Watson p-value, R-square value? Again, same thing.
So
That's the
can-
reason. Huh?
Can you show it once again, sir?
Nothing, sir. Model,
Yes, sir. Model.
ordinal least square.
Sir.
Okay? Then your whatever the dependent variable are there, you can select. Your dependent variable, whatever is there, you take select. Whatever the dummies you have created, select all things together, take this side.
You know, listen.
Each one also you can select, no problem. All together also you can select.
You know.
Okay. Again, interpretation, checking the assumptions, all the things goes same thing again.
So if it is, I made a something wrong, how to recheck it, sir?
Means I am not getting.
Suppose I made it as a constant, suppose I made it as some firm here, I just put it
I am not getting this.
for dependent variable and independent variable. For dummy, this one. If it is, I made a mistakes for the arrow mark and put it to the values. So clicking OK button.
No, then there is a one more way. That's not actually show in equation. So what is your dependent variable you have done? What is the intercept form? Each form also you can get here. The equation gives everything here. You have to type it also.
Okay.
Okay. This is one method. There's one more we said in the fixed different model. What called as? This is called as least square dummy variable model, LSDV.
Yes, sir.
There's one more what you call as we have called as first difference, right? First difference model. That in the beginning slide I have shown you, yt minus 1, xt minus xt minus 1.
Yes, sir.
That I have shown the last one. That is called as a first difference. So first difference model, you go to model here. Okay. Final data. Before to that one. Okay. So now you are trying to do the first differencing.
Yes, sir.
First differencing of what? First differencing, look at here. Again, go to panel. Now you go to panel data, fixed effect. Now your dependent variable. Yes.
You do it here.
Yeah. First difference. Very sorry. So you take at least one so that we be less confusion. I'll take one dependent and one independent variable have taken. Now what we are doing? The fixed effect model, first difference.
First difference.
Okay. In first difference, what you are doing? Now we have taken either of the one. Maybe value we have taken the independent variable. We have to take the first difference of all these things. First difference of dependent variable. First difference of maybe value we have taken. Okay, first difference of value you want to take. So now what to do? Where I got? See, add. Add. Are you following me, please?
Yes.
Yes, sir. Yes, sir.
Okay, add. Yes, please.
Delete ಮಾಡಿದ್ದು.
Hey, delete ಮಾಡಿ ಗೊತ್ತಾಗಿಲ್ಲ ಸರ್.
No, no, no. Everything, whatever extra created, deleted. Model is as same now.
So how to delete it, sir?
No, no, Gretel is very, very user friendly. You can delete anything here. Just you use a delete button. To clean the data, I have done. But all independent variables are same here. Not what are we doing? We are doing.
ಸೆಲೆಕ್ಟ್ ಮಾಡಿ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡು ಮೊಬೈಲ್
Done?
Yes, sir.
Okay. So now, where we are doing add, we are talking about the first difference.
Sir.
First difference of each one. What do you call as? What is the formula? Yt minus t minus 1 equal to xt minus t minus 1. Right? Okay. Now we have to get the first dependent variable first difference. To get that one, what is this? Add. Where is first difference? Here first difference. See, look at here. This is the first difference. But in case what is first difference clear? Add whatever the variable. Now I am taking about the first difference of this one. So select this one. Go to add first difference. Click on this one. You will get the values. So what is this? Just quickly have a look on this one. This is your original data. This is your first difference data. Look at here. This is a different. Sorry.
Yes, sir.
This is the first difference data. What is happening here? Look at here. When you get the first difference, first of all, what is first difference? Lag means previous value.
Previous value.
Lag means previous value. What is the first difference? First difference, look at here. Difference between this and this is your first value.
The difference between 317.
317 and minus 391. Also, you go in reverse way also. Okay. This difference between these two, your first observation, and difference between these two, your third observation. Then similarly, difference between these two, your fourth observation.
Yes.
Difference, that is called the first difference. Right? So now, there is one more observation. Second observation is that in each, when you are taking about the first difference, first observation is missing. For that, because of the reason, because we don't have the previous value for that.
Previous value is not available.
So how many, there is a 10 companies, 10 variables are we are missing. So 190 will be there. So now whenever you are taking the lag values and when you are taking over the first difference, first try to do the linear, the given trend only. If not, then go for the first reference, because if it is not required, don't go. Okay. Then what is that? Where it has gone? Yeah. So then you take the first difference of some any other independent variable. You have two different independent variable. Take first difference of that one also. So this is the add first difference of the any independent variable. Now run the equation. Go to the model. Go to the model. So what is that? Independent variable, dependent variable is investment and independent variable is your first difference value of the value. Just click on this one. (190) observations, 10 or minus here.
So wait, go for it.
Again, what I am telling, now what we have done, first difference of one independent and another independent. You want to take the first difference of this one also, you can do here, add first difference, then first difference of dependent variable, first difference of both the independent variables. Now go to the model, ordinary least square, then I will not take the original values now.
Yes, sir.
Now I will take the difference values. First difference of dependent variable, then first difference of this value and first difference of this value. So all together I have taken, then I click this one. Again interpretation is same.
Yes, sir. Is true. Constant. Correct. Where's the equation? Why? Okay, why?
We are missing here. Yes, the last time is very less. Any other question here? No? Nothing, ma. See, this is the first difference, okay?
Only one individual.
No, no,
One
no.
independent variable.
No, you can take the any number of dummy variables. Dummy variable is as long how many number of your variables are there. The entities, cross-section entities are there. That number of dummies.
Both unit dummies and time dummies.
No. Unit dummies. Unit dummies only. Not time dummies. Time dummies, again it takes into your time series analysis. We are talking about the unit dummies only. Because, why unit dummies again? We want a different intercept for the each units, not the time units.
Therefore, we take a unit dummies for.
Yes. We don't want anything on the time dummies. We need unit dummies. Why unit dummies? We have 10 companies, for 10 dummies we need. That's it. So that time dummies is a different analysis already. Okay? The last one. So how to create also I said here. Any other question?
Sir, can you give that equation just for
Here, sorry,
Model.
model, not model.
Sir, I did one.
Here.
Five.
Five.
View as a
View as equation.
Okay, I got it, sir. Then we will go to cross verification. That's why.
Yes, you should no worry of cross verification. Whatever it is, the result is given at 100% accurate.
So then what about random effect model?
No, I'll come into it. Last. Okay, so any other question here? The last one, another 10 minutes. Any questions? We'll go.
No, sir.
Okay. Now, so the last one is your random effect model, right?
Yes.
So in the random effect model, it is very easy. Go to the panel data, fixed effect or random effect already it is said. Okay. Then click on this one. Here random effect is there. Here random effect is there.
yes.
Yeah.
Yes.
So far we have done the fixed effect. Now the random effect. What is a random effect? Interceptive takes randomly.
Yes, sir, random.
Okay. It belongs to anything or it may be common also you can say. So this is again you take your dependent variables. Independent variable are your value and stock. Value and stock are your independent variables. Same again from zero scratch. This first difference is not required to take. For the previous purpose we have taken. Otherwise you can delete those things also. Nothing. You have to select, say delete. Why it cannot be deleted? Because the window is pop, the model is open. If you want to delete, you can delete also. This was by our original model. Go to model, panel data, fixed or random. Then we'll come into the random. Then already by default, this is a very important method for the random effect model,
So,
Swami Aurora model. Then we'll go for OK. Sorry, we are not selected the dependent variables. So done everything. Go OK. The result is here. Result is here.
Which one?
value ಎರಡನ್ನು ಸೆಟ್ ಬೆಸ್ಟ್ ಕಟ್ ಮಾಡೋ ಈ ಮಾಡಲು ನಾವು ವ್ಯಾಲ್ಯೂ ಕೆಳಗಡೆ ವಿಚಾರ ಮಾಡಬೇಕು ಎರಡು ವಿಚಾರ ಕರೆಕ್ಟ್ ಈಗ
think observations. You have to get osmal result. No, somewhere it is not getting there. Okay, so again, this is the random effect model. Here in this random effect, again interpretation is same. So this is your intercept term, and this is the coefficient, and before to that one, where is your p value? P value is this. This is p value of your model. This is the p value of your model. 0.8061.
That 2 is the actual perfect. Less than and more.
No, for that one is the Durbin-Watson you are talking about. Sorry. This always p values are 0.05 less or more.
Okay, that is Durbin.
Less or more, that is only you have to check. One, I am searching the Houseman test results should come. Yeah, it is here. Okay, why this is so important, I tell you. Now, do you have any questions? So far I am searching for that person, not you. Last 5 minutes I am searching. Okay, now, anything, how to run pooled OLS, how to run the fixed effect model, how to run the least square dummy variable model, how to run the random effect model. Done? All 4 are clear. First thing is that, to conclude, how much? Another 5 minutes you have time?
Yes, sir.
Okay. So, in pooled OLS model, what is the assumption? The poolability should be there. If it is poolable, then only directly run like a OLS. Okay. Then we go to the next model, what is called as fixed effect model. In fixed effect model, the first one we had done, we call as least square dummy variables. That means trying to give the different intercept and try to find which firm or which cross-sectional unit is significant or not. Okay. The last one is what is called as the random effect model. In the random effect model, what we have done, we have just run and the interpretation is same. Again, all the result, it may be Durbin-Watson result or whatever it is, everything same. And if it is some of the results are not satisfying. Say for example, if you want to run, for example, you want to see the residuals. Residuals, again, I will not rename it. It is as it is. Residuals, what is that? It should be 0.0 only. Mean of the residuals should be 0. Is it satisfied? So like this, you have to check any number of these things. But there are, I told you, especially for example, multicollinearity problem can be ignored to some extent in case of pen and data. Okay, some extent it can be ignored. So like this, whatever we discussed in the morning, all the assumptions you need to check. But the question might be arising in your mind, which one we need to accept. Okay, for that only I was checking about this Houseman test, this result. Now, question is that pooled OLS is not a question. Question is between fixed effect model and the pooled OLS model, random effect model. Fixed or random? Either the one you have to use.
Yes.
So, when you run this pooled OLS, now you have to check this Houseman test result. The p value of that one. What is the null hypothesis here? Null hypothesis that is the random effect model is consistent. Random effect model is consistent because we are on the random effect, right? Now we are on the random effect. So we have to, what is the H0? Random effect is consistent. So now the p-value of the Houseman test, if it is more than 0.05, then we are failed to reject the null hypothesis. Fail to reject the null hypothesis is nothing but what? Another way you can say, actually statistically it's wrong to say it is accepted. But statistically you should not say it is accepted. Fail to reject, you can say. Accepted is not a word for a null hypothesis because it is already test driven statement it is. Maybe look at here. They are already written GLS estimate are consistent. GLS is nothing but that random effect model is also called as GLS. Okay. So here it is consistent, it is null hypothesis. Since it is 0.05 more than that one, now you are rejecting the null hypothesis. That means another way you can say it is accepted. That means in all the series, a random effect model compared to fixed effect model is better. Now the data of this one you have to take to your thesis, not the fixed effect data, not the pooled OLS. The results what you get in this table you have to take, because this statistics is better. The Houseman test says that it is a significant here. This is you are rejecting null hypothesis. That means random effect model is consistent. Consistent means so whatever the random coefficient interceptor is taking, no, it is significant. That is the reason. This is what I call as it is the random effect model is better in this for our the data what we have taken. It may be other way. If it is less than that one, less than 0.05, then stop at the fixed effect model itself. If it is less, if it is more, now pooled OLS is random effect model is better. Are you getting my point?
Yes, sir.
So there are three methods: pooled, fixed, and random. Now for my data, the data what we have taken, what is called as random effect model is better. The reason is because this Houseman test result says that more than 0.05 null hypothesis is it is accepted that way. Fail to reject. Fail to reject. Actually, the statistically accepted is not a word for null hypothesis. Null hypothesis. Usually we say, but it's wrong. Usually we say that we accepted null hypothesis. No, we accepted the alternative hypothesis. You can say. But null hypothesis fail to reject because they already usually, and one more thing I'll tell you that usually we set null hypothesis and alternative, not necessarily alternative hypothesis actually, because it's opposite of the consistent, not consistent. But no need. Here you are checking null hypothesis, not alternative hypothesis, whether to accept the null or not to accept. Sorry, reject or not to reject. That is the only thing. Alternative not required. People usually write in the paper. That's actually not the better method. But it's not 100% wrong, you can say. But try to avoid in the days to come. Okay. So this is how whichever the model you can select. Okay. The last, how much time I have? One more point I will tell. Yes. How much time?
115 is there.
Yeah, bande kuttalla, sorry. Workshop malakru nodilla. Okay. Last one more called as endogeneity problem is there. So endogeneity is the what do you call as? This is quickly I will say. So endogeneity problem also comes. What is endogeneity problem? If independent variables are correlated to the error term. Independent variables are correlated to the error term. If the independent are correlated to the error term, then there is a problem of endogeneity. It should be exogenous. Means no relation. Endogeneity is relation. It should not be there. If that is the case, then endogeneity problem is coming. And how to check in the Gretel? How to check quickly? I will tell you that whatever the independent variables, let's say for example, so 2 minutes total. So let's say for example, you have taken what you call as leave out your independent variable. Whatever the independent variables you have taken, take one of the independent variables as a dependent variable and run. Whether result is significant or not, you have to check. So like for example, ordinary square, or maybe this is, so maybe value I will take this the dependent variable, capital stock is the independent variables. Now run the regression, you will get some output. Whether the p value is significant or not, you have to check. If it is significant, there is an endogeneity problem. Are you getting my point? That means both the independent variables are itself are correlated. Then you are not getting the better result there. No, like this, you have to go ahead. Still, it's I am giving you the it is the panel data. One only basic part we have covered. Now we call it GMA model comes. So it develops GMA model, system GMA model. It is now from here it builds. So that is called when there is endogeneity problems are there. How to solve? We can do it there also. So this is how just I had given the endogeneity problem you have to check. And in panel data there is a possibility of endogeneity problem is high because different cross-sectional units are there. Possibilities are there. Okay, so like this it can be continued. So to summarize, first we need to be very strong in the regression analysis, then OLS method, then check the assumption of the OLS. At least there are 4-5 assumptions I said you have to check. Okay, then go to the panel data. Panel data, first whenever the panel data, look at your data, whether it is clean and neat or any missing variables are there or not. You have to check that one. Then upload to your Gradle. Then what you can run, first the pullability check you have to do. It pullable, last just do OLS method and make the interpretation, close it. And the equation is already there. You can make the interpretation that one, R square, Durbin-Watson result, and Durbin-Watson, if these things are not correlating, some of the assumptions are not met, then you have to correct there itself with the different methods. Lag variables you can take, log variables also you take, worst difference also we can take. Making all these things, we can improve upon the models. Then report. If it is pullable, then or else you can go to the fixed effect. In fixed effect, again we have first difference as well as the least square dummy variable. So both the things you can check. And then go for the what is called as random effect model. If the random effect model, if it is a Hausman test, I already told you whether significant or not. Based on that one, you can decide whether you want what you call as, there is a slide in very clearly it is mentioned. I have not gone to the PPT also. So if it is time series less than 3, some parameters are there. I written there also. So you can, I will send to your group. So there you can refer whichever, whether you have to take the fixed or random also. Not only Hausman test, before to testing also you can make some decisions. So with this, or in beginning, just I given a hint that endogeneity problem you can check. And from there again your study begins. You can take it further. Because it is a beginning now. So far we have discussed only basic. Okay? So any questions at last?
Sir,
Hello.
in case of long panel,
Log panel.
long panel, sir. So if I take 100 points,
Okay.
and I am interested in 5-year data,
Okay.
with respect to each firm.
Okay.
So is there any problem I may face because
See, sir, there is always, and I told in the morning also, when more number of time series data, possibility of autocorrelation is high, multicollinearity may be high, as you take the data more, but nothing wrong. So if the data is available, always statistics or econometrics is more data. More the information, better the result. Since you are some people do a combination, just deleting some years, columns. No, more the information is always better. But you have to check the adjusted R square, how it is coming. By improving the variables or improving your time series data, whether adjusted R square is improving or not. How much it is improving. R square always improves. Any dust you upload, your R square improves. But that is not important. That's what I said in the morning. Everybody look into the R square, but adjusted R square is more important one. Because adjusted R square tell that by adding your variables, increasing your time series, so whether information is also increasing. Check both the times. take maybe 3 form, the run, then what is the adjusted R square, or take 4 form, then look at the R square. So, adjusted R square. How much it is changing? If it significantly improves, maybe earlier it is 17, now it is 19. That means it is a very good information. The variable is good mark. So far we had a different kind of a concept where the R square is better, model is better. Many a times I have seen in the research articles, in thesis, R square is good, Durbin Watson is very, very less. That's what I said. Always, again, underline also I said, don't take it 100% the same statement, but the most of the time is that R square value should be lesser than the Durbin Watson result. And also R square is good, somewhere I have seen that the P value of the F statistics is very low, not significant. We cannot say that model is good. So lot of combinations are there. So ultimately, what is that? In a very, very simple terms, we can say that your beta naught and E should be less. Or in the other sense, in the morning I said, in TSS, your RSS and ESS should be less. In any technical way, you can say. As less, model is better. Any other thing? Okay? So, with this, thank you so much, everyone, giving attention, and thank you, Sidhu sir and CMDR. Thank you for giving me this opportunity. I hope given the value added to something to your learning also.
Yes, sir.
I know it's an afternoon session, some are awning also. Luckily, nobody is sleeping, trying to sleep, not sleeping. Okay, I could have been come to all your level, but what has happened? I looked into the time parameter also. So I thought coming to your people, it takes a lot of time. It's not a classroom also. Okay. With this, once again, I thank everyone. Thank you so much.
On behalf of CMDR and my own behalf, on behalf of all the participants, I take this opportunity to thank Professor.
Thank you.
Manoj Dolli sir, coming over here and giving a wonderful this one presentation as well as practical also they have done. We are very grateful to you, sir. Thank you.
Thank you. Thank you.
So yesterday we are in your guest house, sir. It's good, sir.
Guest house
It's good, sir, actually.
ನಮ್ದು ಇದರ ಪ್ರಾಬ್ಲಮ್ ಸರ್, ನಮ್ದು ಪೇಯಿಂಗ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ ಅಕಾಮಿಡೇಷನ್. ಬೇಗ ಬೇಗ ಹೋಗಿದ್ರೆ ನೆಕ್ಸ್ಟ್ ಇದ್ದಾರೆ.
ಎಷ್ಟು ಲೇಟ್ ಮಾಡಿದೆ ನಾನು?
1 hour.
ಲೇಟ್ 30 minutes, sir?
30 minutes, 45 minutes, sir. 1
Sorry. ಆ ಕಡೆ ಕೇಳಕತ್ತೀನಿ ನಾ ಟೈಮ್ ನಿಮಗೆ.
1:15 ನೋಡಿ, ಜಲ್ದಿ ಊಟ ಮಾಡಿ ಬರ್ರಿ. ನೆಕ್ಸ್ಟ್ ಈಗ ಟೈಮ್ ಸೀರೀಸ್ ನೆಕ್ಸ್ಟ್ ಕಲಿಬೇಕ್ರಿ, ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಬೇಕು ಇವನ್ನೆಲ್ಲ ರೀ. ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ರಿ ಮಾತ್ರ, ಇಲ್ಲ ಕಲ್ತ್ರಿ ನೋಡ್ರಿ ಮರ್ತು ಬಿಡ್ತೀರಿ. ಪ್ರಾಕ್ಟೀಸ್ ಇಟ್ಟು
ಇಲ್ಲ, ನಾನು ನಿಮ್ಮ ಪಾಯಿಂಟ್ಸ್ ಕವರ್ ಮಾಡ್ಲಿಕ್ಕೆ